Okay, so good afternoon. Let us discuss now yung ating AC circuits. So again, basta circuits, isa lang pag-uusapan natin lang. So that is only Ohm's law. Now, the only difference, pagdating sa AC circuit, since under AC circuits, o yung tinatawag nating alternating current or alternating quantity, so kung sa DC circuits, we are dealing with pure magnitude only, no? Pure magnitude. So ngayon, pagdating dito sa ating AC, no? Alternating quantity, so usually, ang pinag-uusapan na natin is mga vector quantity. No? So pag sinabi vector, that is defined by magnitude and direction. So basically, our computation now, yung ating Ohm's law, no, it will be computed using the complex number analysis. So complex number na ang gagamitin natin dito to compute for your voltage, current, power, okay, and any given parameters na required dun sa ating problem. But still, no, nandun pa rin tayo sa Ohm's law. So, hindi tayo lalayo kay Ohm's law. Okay, so, pagka kinuha natin yung ating alternating quantity at pinlat natin siya, kapatid, okay, so pag pinlat natin or kinuha natin yung curve ng ating alternating quantity. So basically, kung babalikan natin yung ating dynamically induced voltage, that is the induced voltage do sa ating generator and motor. So E is equal to beta LB multiplied kanina, no? You have sine theta. So ibig sabihin that the given generated or induced voltage, that is directly proportional to the value of our sine functions. Kaya kapag pinlat natin yung ating alternating quantity, either voltage or current, so usually yung ating curve, ang tawag natin is what? Sine wave. So tinawag siyang sine wave since its given functions that is always proportional or rely on the value of our sine functions to sa ating trigonometric functions. So therefore, let us consider yung ating x and y axis here. Pwede natin sabihin this is the axis for a value of t, the time elapsed at which the given rotor rotates along the magnetic line of force, or pwede nating express yan as the axis for our omega t. So sino yung omega? That is the angular velocity. Gaano ba kabilis umikot yung ating rotor within the magnetic line of force, or pwede nating express yan in terms of angle P. So pwede yan. Pwede nating i-measure yung ating x-axis in terms of time or in omega times t. So this is angle. So that angle pwede natin siya as angle P. And yung ating vertical axis, kung voltage yan, so that is in terms of voltage. Kung current yan, in terms of current. Kung power yan, so in terms of power. So let us consider here, express na lang natin in terms of voltage. So pwede natin kunin ngayon that the general equation of our instantaneous voltage or alternating quantity, so you have your E equal to okay? So that would be the general equation for our alternating quantity. So in this case, voltage ang pinag-uusapan. So anong meron dyan? Wherein E sub M, that is the peak or the maximum value. So kailan natin makukuha yung maximum value? So based on this given waveform, ayan yung ating maximum value. So this would be our maximum value. So this would be our E sub M. Now, alam natin, for one complete cycle, so from one complete cycle, so this is the positive alteration, this is pi or 180 degree, and this is 2 pi, or that is one complete cycle, which is equivalent to 360 degrees. So ibig sabihin, we may always consider that the maximum value always occur at what? Pi all over 2, or that is at 90 degree. No? So that would be when the angle theta, kasi si theta here, That is the angle between the magnetic line of force o yung ating flux at saka yung ating conductor. So if this given theta is maximum or sine theta is maximum, so the value for this voltage is maximum. Kailan magiging maximum yung ating sine function? That is always at what? Pi all over 2. Kaya alam natin, lalabas yung maximum value ng isang alternating quantity at a given angle equivalent to 90 degree. So E sub m is the maximum value for our alternating quantity. At this case, we are dealing with voltage. Ano? Okay. Then our omega, so this is the angular velocity, which is always equivalent kanina 2 pi f measured in radian per second, wherein f, that is the frequency, and t is the given time. Then itong theta na to, that would be its phase angle. So ano yung phase angle na yan? So tulad ng binanggit natin kanina, for this alternating quantity, ang pinag-uusapan natin, we are dealing with vector defined by its magnitude and direction. So the phase angle represent its corresponding direction. So anong direction din yan? So this phase angle also represent what would be the distance or the phase difference of this waveform to our origin or do sa ating reference. So yung reference natin, no, kapag pinlat natin using Argand's diagram, so yung ating x and y axis kasi tawag natin dyan is Argand's diagram since we may plot real at saka imaginary. So yung origin o yung intersection ng x and y, that will be our reference. Ibig sabihin, kung yun ang reference palagi, ang angle dyan is at what? 0. Kaya kapag kinuha natin yung distance nitong ating waveform, no? Yung kanyang starting point doon sa ating origin, that always represent the phase angle. So dito sa ating illustration, nilagay ko yung ating waveform that is at origin. So at this case, this phase angle is what? 0. Now, kailan siya magiging positive, kailan siya negative? So meron tayong waveform that start before the origin. So let's say, ito yung ating waveform na kailangan i-consider. Ano? Assuming for this given waveform, ito yung ating starting point. So kapag kinuha natin yung distance between the starting point at saka yung ating origin, ito ngayon yung ating phase angle. So anong sign yan? Positive ba or negative? So pag sinabing positive or negative, it only represent leading or lagging. Now positive yan, leading. Negative yan, lagging. So kanino siya leading, kanino siya lagging? Since the phase angle, ito yung angle between the waveform at saka yung origin. So therefore, by just comparison, sino bang nauna? Sino bang nauna? Yung ating waveform o yung origin o yung ating x and y axis. So in this case, mas nauna yung ating waveform. So for this instant, the phase angle, it should be what? Positive. So it represents, it start before the x and y or before the origin of your Argand's diagram. Now, in case yung ating waveform start after the origin, let's say ito yung ating waveform na kailangan i-consider. So if we try to get the distance of its starting point to our origin, no, ito yung kanyang phase angle. So at this case, dahil nahuli yan, no, andito na si origin, ito pa lang, no, dito pa lang mag-start yung ating waveform. So at that case, it is known to be what? Lagging. So kung lagging yan, this is what? Negative. Okay? Nakuha ba? So that would be our alternating quantity. Now, ang tawag natin kay small p, this is the instantaneous value. So tinawag siyang instantaneous since its value changes with respect to any particular time t. So simula dyan, paliwas ka ng certain number of seconds, so you may get the value of your induced voltage. So after a certain number of seconds ulit, iba-iba ulit ang kanyang value. Kaya ang tawag natin, that is always instantaneous values. Now, pwede nating express yung sinusoidal waveform na yan into vectorial form. Pag sinabi nating vectorial form, instead of waveform, So using the same Argand's diagram, pwede nating express yung ating alternating since alam natin that is a vector. So pag sinabing vector, it is expressed by what? A particular arrow. So eto ngayon, let's say that would be the voltage. Ngayon lang, kapag naka-vector form tayo, take note, the length of the arrow represent the magnitude of the corresponding alternating quantity. Yun nga lang, yung magnitude na yan, it represent its corresponding RMS value. No? Capital letter. And this given angle, ito yung kanyang phase angle theta. Kaya kung leading yan, nasa taas siya, positive. Kung lagging yan, nasa baba. No, magiging reference natin itong x and y axis. So kapag lagging, nasa baba. So dito, start at origin, so nandito siya sa 0. So sino to E? So this given E represent the magnitude of your alternating quantity in terms of vectorial form. Pag naka-vectorial form yan, dapat ang magnitude niya represent your what? RMS value. Ano yung RMS value? So RMS value, yung iba, ang tawag nila is what? Effective value. O yung iba, true value. So mamaya explain natin paano pagkuha ng RMS value. So in terms of waveform, that is sinusoidal. In terms of vector form, so para ka lang merong arrow, its given magnitude, that is the RMS value of that quantity. Kung voltage, RMS value of voltage. Kung current, RMS value of current. Now, its given phase angle represent the angle between that vector and the x-axis. Kaya it represent that is what? A direction. So, balikan na lang natin yung different topic na pwede pa natin may counter as we try to solve this given problem. So, number 1, the sinusoidal voltage wave has RMS value. So, binigay nga yung ating RMS value of 70.71 and a frequency of 60 Hz. Determine the value of our voltage 0.001, 0.0014 seconds after it crosses the omega t axis. So kapag pinlat natin siya kapatid, using our Argand's diagram, oops. Okay, so draw na to scale, assuming this would be the equation of our voltage. So you have E equal to its maximum value sine. So at this case, omega t, let us consider its phase angle that is equal to 0. So now, hinahanap ng problem, let us consider after this waveform crosses the omega t axis. So ito yung ating omega t axis, the x-axis, which is sabihin natin that is the axis for our angle t. So palipas tayo ng certain period of time, sabihin natin, let's say, simula sa origin up to this point, this would be the value of our t. So the value of this given t required what would be the instantaneous value of this given voltage at t is equal kanino? 0.0014 seconds. So kapag kinuha natin yan, ipoproject ko lang ito pataas kung saan tumama sa waveform. I-project natin horizontally to the y-axis. So that would be our instantaneous values. So para masolve natin yan, kakailanganin natin yung maximum value. Eh anong binigay? So based sa problem, if we try to consider that the RMS value of this given voltage, so sabihin na lang natin capital letter without subscript, represent the RMS value for our voltage, which is equivalent to 70.71 volts, wherein the frequency is equal to 60 Hz. So alam naman natin Kung walang binigay na frequency, automatic, we have to consider the standard frequency here sa atin, which is equivalent to 60. So ang tanong, how to get the maximum value if given is the RMS value? So for alternating quantity, we have different value to be considered. So meron tayo, unahin natin yung average value. So sino ba si average value? So kung ang kailangan natin is the flow of electron, the average flow of electrons. So usually, the quantity to be considered for your alternating quantity is the average value. So such as sa ating mga rectifiers. No? Usually, ang kino-consider natin is the flow of electron. So we are getting the corresponding average value. Sino ba yung rectifier? We convert the AC to DC. At pag kinuha natin equivalent DC, ang computation, that is by getting the average value. Paano nga ba kumuha ng average value? So generally, pag kinuha natin yung average value sa geometry, it is always the area over kanino? Span. So yung area, that is the area covered by this given waveform. So average value should be computed within one complete cycle. No? Within one complete cycle yan. Kaya pag sinabi natin span, gano'ng kahaba ba yung ating waveform? So that is the length of our one complete cycle, which is always equal kanino? 2 pi or 360 degrees. Now, for sinusoidal waveform, tawag natin sa waveform na yan is symmetrical values. So ano ibig sabihin? Pag sinabi symmetrical, balance. So yung value sa positive alteration, ito yung positive half, ito yung negative half kasi nasa taas positive, sa baba negative. So sine wave is symmetrical. Pag sinabi symmetrical, the value sa positive side, it is equal kanino? Negative side. Kaya kapag kinuha mo yung average value at kinonsidered mo yung one complete cycle for sine wave, automatic, no need to solve, magiging zero yan. Okay? Zero ang lalabas. Kaya to get the average value for our sine wave, ang ginawa, special case. To get the average value for our sine wave, the average value for sine wave, it is only computed within one half cycle. So kung within one half cycle, babalikan natin, ito, from 0, one half cycle, so this is what? Pi. So ang kailangan lang natin gawin ngayon, let us just consider the area under one half cycle. One half cycle lang kinonsidered kasi pag whole cycle yan, magsisiro siya kasi symmetrical. So ang tanong ngayon, paano natin kukunin itong area na yan? So doon papasok yung ating integration. So to get the area for this given waveform, so gagamit tayo ng vertical strip. Natin, ito yung ating vertical strip. So getting the area for this vertical strip, ano magiging equation natin? So lumalabas for this vertical strip, ang kanyang height is the E at yung kanyang base, that is the change in the angle P. Kasi that is along P axis. So therefore, pwede nating express ang equation ng ating alternating quantity as maximum value P sub M sin si omega t, gawin natin siyang P. Kaya kapag kinuha natin ang kanyang average value, it should be equal to area. Ano area? So by integration, that is the integral of what? E dp. Anong limit? Supposed to be 0 to 2 pi. No, one complete cycle. Eh since magsisira yan, kaya kinuha for sine wave, half cycle na. Kaya kukunin lang natin area from 0 to pi. Kaya ang limit, 0 to pi. Then, ano span? Gano'n ba kahaba yung ating area? So that is only equal to pi. So kapag kinompute natin, you just substitute. Ano? Meron ka integral of maximum value sine p dp from what limit? 0 to pi. Nakadivide kanino? Pi. So meron ka ngayong maximum or average value. So kung integrate natin, i-region ko na lang ang calcu. So I just integrate the sine function from 0 to pi. Ano? Then equal ko, anong lumabas? 2. So ibig sabihin, its average value is 2 over pi multiplied kanino? maximum value. So this formula for average value, it is only applicable for what? Sine wave yan. No? So sine wave lang yan. So ibang waveform, iba-iba average value. Sir, ba't kinuha natin si average value? Kasi kung kukunin natin si RMS, no, para meron kang idea bakit siya tinawag na RMS. RMS, that is only based on the mathematical equation on how to compute or how to get its corresponding value. So tinawag natin siyang RMS value since that is root mean squared. So mean is the average value, square mo siya, then kunin mo yung kanyang root. So ibig sabihin yan, ano yung average value natin? That is the integral of E dp. Squared mo siya ngayon. So nakadivide ko sa ating length. So dito, alam natin, dapat yung kanyang span is one complete cycle. So it should be divided by 2 pi. Ang magiging limit mo, 0 to 2 pi. Okay? Then, dulo, square root. Okay, tinawag siyang RMS value or root mean squared. So, ibig sabihin, kapag sinubstitute natin dyan, meron akong square root sa loob, integral of e squared. So, you have maximum squared sine squared theta, not theta, p, dp. So, in this case, one whole cycle, 0 to 2 pi. Ano span niya? That is what? 2 pi. So, pwede muna natin kunin yung sa loob, that is sine of alpha x plus 1t squared from what limit? 0 to 2 shift pi. So, makukuha natin ang values niyan. So, that is simply pi. So, integral of sine squared theta or sine squared p dt, that is simply pi. So, pi over pi cancelled out. Anong natira? Em squared over 2 na lang. So, pag in-square root mo yan, kaya lalabas, the RMS value, it is simply equal ka, no? Maximum over square root of 2. So, that is now the RMS value for our waveform. So, take note, that formula, it is only applicable for what? For your sine wave. So, in that case, alam na natin kung paano pala kunin yung RMS value. So, in that case, solving now for the value of instantaneous voltage at t is equal to 0.0014 seconds. So, pwede na nating i-substitute ngayon that E is equal to, so maximum value, lumalabas, that is simply the RMS value multiplied kanina. Square root of 2. Ito yan, di ba? Kailangan na nito, E times square root of 2, multiplied na lang natin kanina. Sine omega, ano ba ng omega? That is always 2 pi f. Then multiplied natin yung given time. Now, take note na lang para exacto, the value of our angular velocity, it is in what? Radian per second. So, dapat ang calculator mo, i-radian mo or you convert the value into degree kung ayaw mong mag-radian. So, i-radian mo na lang para hindi ka na lang kailangan mag-convert. No? I-radian mo na lang yung iyong calculator. So, in that case, pwede na natin i-substitute. So, the RMS value is 70.71. Multiplying it by square root of 2, we can have its maximum value. Sine. So, ano frequency? 60. So, 2 pi times 60. Approximately, that is 377.0014. So, take note, calculator is the square root of 2 to make it maximum value. Then, this 2 pi f, 2 pi times 60 is 377 times the given time of 0.0014. So, kung anong binigay ni Calcu, and that would be the instantaneous value for our voltage, 0.0014 second from the origin. So, ano lumabas? To have 50.36 volts. That should be the answer. Meron ba? 50.36. So, 50 volts will do. So, the answer would be balik that. Nakuha ba? Any question regarding problem number 1 on how to compute the instantaneous value of our voltage? instantaneous value of our voltage. So take note na kung paano kunin si average value at kung paano kunin si RMS value. So this is specific formula. This is only applicable for sine wave only, no? Pang sine wave lang ito. So pag binago yung waveform, iba na ang kanyang average, iba na rin yung kanyang RMS value. Okay, so iwanan ko si number 1, number 2. So sino si number 2, no? Number 2 is form factor. Sino ba yung form factor na yan? So to get your form factor, okay, so medyo na-disconnect lang yung aking laptop. So form factor, that is only a conversion factor between RMS and average. So therefore, for sine wave, pag kinuha natin yung kanyang form factor, so form factor of our sine wave, f sub f, sabihin natin, so we have already identified that the RMS value for your sine wave, that is always the ratio, whatever its maximum value, nakadivide lang kanino? Square root of 2. Now, to get its average value, that is 2 over pi, multiplied whatever the maximum value. So, ibig sabihin, kung current yan, maximum value of current. Kung voltage yan, maximum value of voltage. So, kapag dinivide natin yan, kung isang quantity ang pinag-usapan, we may cancel out its maximum value. So, anong matitira? This is now only equal to pi over kanino? 2 square root of 2. So, kapag kinumpute natin yan, it is exactly 1.11. So 1.11, that is only form factor intended for what? Sine wave. No, pang sine wave lang yan. Kapag ka naging triangular wave, square wave, okay? So tooth wave, circular wave, iba-iba ang kanilang form factor. So anong letter ito? So that is arriba. Okay? That is the formula for your form factor. So usually form factor, parang kinuha lang natin yung conversion factor between the RMS and average value for any corresponding alternating quantity. So general formula, RMS over average value. Number 3. So for number 3, find the RMS value of an alternating current with instantaneous equation. No? So the instantaneous equation of our current, that is 10 sine omega t plus you have 5 sine omega t plus you have 2 sine 5 omega t ampere. So what would be its corresponding RMS value? So let us consider capital I na lang. No? So paano ba natin kunin yung RMS value for this given waveform? So to get the RMS value or the resultant RMS value for this waveform, So the integrate or the derivation that is also by integration. Nga lang medyo mahaba-haba pag in-integrate pa natin, ano, since sine wave yan. So pwede nating i-generalize. Ang tawag natin dyan is complex waveform, or sa iba, sa EE natin, ang tawag natin is mga harmonics. Tinawag siyang harmonics kasi if you try to consider, the frequency of every alternating quantity increases by a factor of n. No? So from fundamental, third harmonics, fifth harmonics, so on and so forth. So tinawag naman natin siyang complex form since for any alternating quantity that is considered, no, in terms of current, so generally, pwede natin express yan as what? No? Ay DC plus the summation of your maximum current sine and omega t as n approaches to 1 or n equal to 1, then approaches to infinity. So kung voltage yan, BDC, then you have AC waveform or AC form. Kaya tinawag siyang complex waveform kasi for this given instantaneous or alternating quantity, it is known to be complex since most of the time meron tayong constant part. So the constant part of our waveform usually represent the DC component. So kaya tinawag siyang complex waveform, meron siyang DC component at meron siyang AC component. So ngayon, kung wala yung constant part, ibig na sabihin yung kanyang DC component, it is only what? Negligible. So for this given type of complex waveform, to get its RMS value, so basically, this is also by integration. No? So hindi na lang natin i-derive. The RMS value for this complex waveform, that is only equal to, pag tinanong natin, para lang siyang resultant force. No? So that is whatever the DC component is squared mo plus you have the summation of maximum value for any alternating quantity is squared mo, i-divide mo na lang na 2. So that is now the RMS value for this given waveform. So itong DC component, that is the constant part dun sa ating instantaneous equation. So kung wala yung constant part, alam mo na constant part yan kapag wala na yung ating sine functions. Okay? So dito, yung ating DC component or the constant part, that is only what? 0. Ang meron lang sa kanya is only the AC component. So ito yung mga maximum value per AC component. The maximum value for fundamental harmonics. Tinatawag natin siyang fundamental harmonics since that is the reference frequency. So this is the third harmonics. So third harmonics yan, since the frequency, it is now multiplied by 3. And this is the fifth harmonics, so on and so forth. Kung meron pang marugtong. So since pag wala yung ating DC component, so sabihin na lang natin at DC component, it is equal to 0. So therefore, the RMS value for your complex waveform, that is just simply the square root of summation of whatever the maximum value per harmonics, i-divide na lang natin kay 2. Sir, bakit maximum value squared? Kasi kapatid, pag tinanggal natin itong square root na yan, para matanggal yan, square natin both sides. Tama ba? So, square ko na lang. So, lalabas, this is squared. Now, kung babalikan mo yung ating RMS value for sine wave, di ba RMS value, that is the maximum value over what? Square root of 2. Kaya kapag in-square mo yung RMS value na yan, so you have RMS value equal to maximum value squared divided by 2. So parang lumalabas that this value, it is actually the RMS value per waveform. So this is the RMS value of per sine wave, RMS value of the third harmonics, RMS value of the fifth harmonic. So lumalabas, pag kinuha mo yung RMS value ng buong circuits, ito yung tinatawag natin sa mechanics na resultant force. Ano yung resultant force? So that is a single force that would have same effect as two or more forces acting on a given body. So pwede natin palitan yung RMS value nitong tatlong waveform na yan by single RMS value. At sino yun? That is the RMS value for our complex waveform. No? Kaya ito yung kanya naging equation. It represents the resultant value. Gets ba? So therefore, no more problem. Pwede na natin kunin ngayon that the RMS value for this given current, let's say capital I, without subscript, that is RMS value. So we have only equal kanina square root. Ano maximum value ng fundamental harmonics? So fundamental represent the multiplier of your angular or omega is simply 1. So that is 10. Squared mo, summation, so plus. Maximum value of the third harmonics. So that is 5. Maximum value of the last harmonic. So that is 2. So ngayon, lahat yan, i-divide na lang natin ng 2. So meron na tayo RMS value. Okay, baba? So you have 10 squared plus 5 squared plus 2 squared. Divide na lang natin ng 2. That should be the answer. So you have 8.03 ampere. So pwede mo ngayon palitan ito ng isang waveform with RMS value of 8.03 that would have also same effect as this given waveform. Nakuha ba, kapatid? So that is the RMS value for our complex waveform. Okay, so ano letter yan? Ayun, that is a Dog's type. Kung wala siyang constant part, ibig sabihin, DC component, it is just what? 0. So malalaman mo meron yung DC component yan. Let's say dito, meron kang plus 12 o 12 plus. Meron ka rito, let's say, meron ako dito 12 plus 10 sine omega t. So this value, wala na siyang sine function. So this is a constant. So lumalabas, ito man yung possible DC component. Kung meron tayo pure constant lang, it represent the DC component dito sa ating complex wave form. Kaya sa tinawag na complex, it contain DC and AC component. Tinawag naman siyang harmonics since the frequency of our waveform increases by a factor of n. Fundamental, third harmonics, fifth harmonics. So ito yung waveform na kapag sinukat mo using oscilloscope na dapat smooth yung ating waveform, so makikita mo yung waveform mo meron siyang distortion, distorted, no? Parang may spike doon sa ating waveform. So tawag natin doon harmonics. So pagka hindi smooth yung ating waveform sa power system, usually represent losses. Kaya sa power system, so as much possible, tinatanggal yung mga harmonics na yan. So tinatanggal kasi mga distortion ng mga harmonics. So every distortion represent losses. Okay, so iwan ko si number 3. So let us try number 4. So number 4, before ko siya isolve, although simple lang yan, babalikan lang natin yung tinatawag natin frequency response. So pag sinabi lang natin frequency response, it would be or it represents the behavior of our different electrical parameters when connected across AC source. So meron lang naman tayong tatlong electrical parameters, yung resistance, inductance, and capacitance. So ito napakasimple pero napaka-importante lalo na sa circuit analysis in dealing with alternating quantity. So kailangan kabisado natin ang behavior ng ating circuit kung meron na siyang resistive, inductive, or capacitive. So let us consider if the given circuit is only pure R, okay, or purely resistive. Ibig sabihin, yung ating component, yung electrical component lang natin, ang makikita mo lang is simply resistance. No? Resistance lang yung connected. So ito, hindi ko na i-derive. So ito, tatandaan natin. For voltage and current, yun ang palagi natin i-consider. So kapag purely resistive, ito yung kailangan natin i-consider that the voltage E and current are in phase. So pag sinabi natin in phase, they have the same direction. So, ibig sabihin nun, whatever the angle ng ating voltage, it should be equal sa angle ng ating current. No? Whatever the phase angle of your voltage, equal sa phase angle ng ating current. That is only applicable during purely resistive. Ibig sabihin, pure R, wala kang ibang makikitang parameter sa circuit kung hindi R lang yan. So kapag pinlat natin using phasor diagram o yung ating Argand's diagram, para meron tayong idea. So let us consider kung nandito si voltage, so assuming this would be our voltage E, the RMS value of our voltage. So alam natin si resistance, real number din si resistance. So the resistance is also along the x-axis. So ito yung ating resistance. So kaya pag kinuha natin si current, dahil in phase yan, so kung nasaan si voltage, nandun din yung ating current. Yun nga lang, mas maliit lang ang kanyang value. So ito ngayon, yung ating current in the purely resistive. So pag in phase, ibig lang sabihin, they have the same direction. Okay? So that is only true kapag meron tayong purely resistive. Now, let us consider naman yung ating purely inductive. For purely inductive, meron lang tayong inductance. No? So kung babalikan natin yung ating equivalent circuit, okay, so we have the source voltage and you have the inductance. Therefore, we have the circulating current. So let us consider, no, unless otherwise, so ibig sabihin, pag walang binanggit sa phase angle ng voltage, sabihin natin siya yung ating reference. No? At all cases. No? Pag walang binanggit sa angle ng ating voltage, siyang gawin nating reference. So ibig sabihin, its phase angle that is at 1, 0. And let us consider now, at phase angle of voltage 0, the source voltage E equal to whatever the maximum value multiplied natin kanina, sine omega t. So therefore, since meron ka lang inductive load, purely inductive connected to your source voltage, so lumalabas, whatever the source voltage, that is the voltage drop across inductance. Tama ba? So kung babalikan natin, generally, voltage drop across the inductance, anong formula niyan? L di over dt. So since siya lang naman ang load natin sa ating AC circuits, so in that case, the voltage drop across this coil represent the source voltage or equivalent to sa ating source voltage. So equal yan kanino? E sub m sine omega t. Therefore, solving for the equation of our current, so pwede natin i-cross multiply yan. Anong lalabas? That d sub I, it is equal to E sub m, divide natin kay L, omega t dt. So therefore, to get now the corresponding current, applyan natin ng konting mathematics. You have to integrate both sides. Anong makikita natin? That the given current, it is equal to E sub m over L, integral of sine. So dating sine, gagawin mo lang cosine. Kaya lang, ano siya? Negative. Ano derivative ng ating angle? Omega t, derivative nito is omega dt. So wala tayong omega, dt lang. Kaya meron lang tayong balance factor of 1 over omega multiplied kanina cosine omega t. So therefore, pag sinimplified natin yan, ito makikita natin that E sub m over omega L naka-multiplied kay negative cosine omega t. So, ano ba ang value ng negative cosine omega t? Kung babalikan mo doon sa ating trigo, sum of two angle for sine. So, balikan natin, sine of A plus or minus B. Ano equivalent niya? Diba ito si sine A, cosine B, pag plus plus din, pag minus minus. Cosine A, sine B, yung ating sin, cos, cosine. Now, try to consider, if we try to represent A is the value of your omega t, and let us consider B as 90 degree, so anong lalabas sa equation? So, it would be equal kanino? Sine omega t cosine 90 plus minus, so this is cosine omega t sine 90. Now, alam natin, sine 90 is 1. Cosine 90, it is just what? 0. So, ano ibig sabihin? Lumalabas, after we simplify this equation, so this value, sine omega t plus minus 90, it is just equal kanino? Plus minus of what? Cosine omega t, which means si negative cosine omega t, it should be sine omega t minus 90. Kapag positive cosine, it should be plus 90. So, ibig sabihin, at this case, na-express natin ulit yung equation ni Karen in terms of sine wave. So, you have omega L multiplied kanina sine omega t minus what? 90. So, kung babalikan natin, pwede nating express ito in terms of what? Maximum value of our current. So, this should be I sub m, which is equal to E sub m over what? Omega L. Now, kung babalikan natin sa Ohm's law, na yung ating current is the ratio of voltage over the resistance. So, ngayon, yung resistance na pwede natin i-consider, sino siya? Si omega L. So, ang tawag natin sa resistance offered by the inductance, no? Sino yung resistance niyan? That is the resistance offered by the inductance in the flow of current. So, mas kakilala natin as what? Reactance over what? X sub L. Kaya pala yung ating X sub L, it is what? Omega L. Now, itong kailangan natin tingnan dyan. At purely inductive, ang voltage natin na kanino? Na kay 0. So ngayon, nasaan yung angle ng ating current? So based on the given equation, we have clearly found out that the phase angle of your current is at what? Negative 90. So anong ibig sabihin? At pure L, eto siya. The current I lags the voltage by how many? By 90 degree. And the opposition offered by the inductance to the flow of current, it is known as the inductive reactance, which is equal kanino? Omega L. Kaya kapag kinuha natin yung kanilang phasor diagram, okay ko rito. So kapag kinuha natin yung kanilang phasor diagram, so reference natin ulit si voltage. So nasan si voltage? Nasa x-axis. So this would be our voltage. So nasan ngayon yung ating current? So since the current that is at negative 90, laging siya. So andito ngayon, oh, nandoon si so ito yung ating voltage in terms of RMS value. So the current, it should be kung laging yan sa nasa baba. So andito yung ating current sa ating inductive circuit. O sabihin na lang I. So therefore, by Ohm's law, saan ngayon yung direction ng ating X sub L? So the X sub L, that is at the positive y-axis. No? So ito ngayon, yung ating X sub L. Kaya nga yung kanyang angle is at positive 90. So ito yung ating X sub L, no? By Ohm's law. Kaya nga alam natin sa Argand's diagram, yung ating y-axis is the axis for imaginary. So sa taas, positive j. Sa baba is what? Negative j. And the x-axis is the axis for what? Real number. Kaya si x sub L, nasaan siya? Positive 90. Okay? So that is the behavior. Ang importante dyan, no, alam natin, at purely inductive current lags the voltage by how many? 90 degree. And the opposition offered by your inductance to the flow of current, it is known to be as reactance, which is omega L, and it is at what? Positive 90. So now, hindi ko na i-derive kung paano naman yung capacitive. Ganyan din naman ang kanyang idea. So therefore, for purely capacitive circuit, so ibig sabihin na makita mo circuit parameter, it is only capacitance. No? So ito ay napaka-important, simple lang, pero ito yung kailangan natin, lalo na pagdating sa mga network analysis ng AC. So napakalaking tulong, alam natin ang behavior ng ating mga circuit parameters when they are connected across an alternating point. Yan, then you have our C. So again, you have the capacitance, you have the source voltage. Ulit, gawin natin siyang reference. This angle is 0. So we have now the circulating current I. So dito, hindi ko na i-derive. So alam lang natin that the voltage drop across capacitor, it is always equal to 1 over C integral of what? IDT, which is equal to sa ating source voltage. Ang source voltage natin is of M sin omega t. So para makuha mo naman ito kapatid, anong gagawin mo? You differentiate. Okay? I-differentiate mo naman ito. So ngayon, hindi ko na siya i-differentiate. So lalabas diyan kapatid, ito na yung kanyang summary that at purely capacitive circuit, your current I leads naman voltage by how many? 90 degree. And the opposition offered by the capacitance to the flow of current is the capacitive reactance, which is equivalent to 1 over omega C. So kapag kinuha natin yung kanilang phasor diagram, pag pinlat natin yan, so ulit, ang reference natin is si voltage. So palagi, that is at 0. So kung nandyan yung ating source voltage in terms of RMS value, so your current naman, since leading yan, so nandito na siya sa positive y-axis. So ito na yung ating current. So therefore, by Ohm's law, to get the value of your resistance is voltage over current. Kaya kapag pinlat natin kung nasaan yung ating X sub C, nasa naman yung ating X sub C? So your X sub C, that is actually at what? Negative y-axis. Kaya yung reactance ng ating X sub C, it is always at negative imaginary. Okay? So, yan yung mga tinatawag natin frequency response. Ayan ang behavior ng ating resistor, inductor, and capacitor when they are connected across an AC source. So, simple lang pero napaka-importante ng mga frequency response na yan. Pag resistive, in phase. Pag inductive, no, pag purely inductive, current lags, mahuli si current kay voltage ng 90. Pero pag purely capacitive, mauna yung ating current kay voltage ng 90 degree. So therefore, kay problem number 4, we have only purely inductive. No? For number 4, let us see, we have purely inductive circuit. So, nagbigay ng current, 5 ampere. Hindi binanggit kung sinong current yan. Automatic, Pag nagbigay ng value ng current voltage sa problem at hindi in-specified kung maximum value ba yon, instantaneous value ba yon, maximum value, average value, automatic, it should be what? RMS value. So the RMS value of your current is 5 ampere, wherein the RMS value of our supply voltage, that is also 110 volts at a given frequency of 60 hertz. So, ano hinahanap? What would be the inductance? So, to solve for the inductance, pabalikan lang natin that the inductive reactance of a given purely inductive, it is always equal kanina, omega L. At yung inductance na yan is the opposition offered by the inductance to the flow of current, which represent the resistance. Kaya by Ohm's law, ang resistance is the voltage over the current. So ngayon, kung RMS ito, dapat RMS ito. Kung maximum ito, dapat maximum ito. Nakuha ba? So walang problema kung gagamitin mo yung maximum for voltage. See to it that maximum din yung gagamitin mo kay current. So walang problema kung RMS value ito, dapat RMS value rin yung current. So ibig sabihin, dapat consistent ka lang. So walang magiging problema, the same pa rin ang lalabas na sagot. So therefore, pwede na natin sabihin that the value of our inductance is equal to voltage 110, current that is 5, i-divide na lang natin ng omega. 2 pi f, again, f is 60, so that is what? 377. So meron na tayong inductance of the circuit. So that is only 58.35. millihenry. Yun ang solution dun sa ating problem number 4. Ganun lang siya ka-extra. Basta kabisado na natin yung kanyang behavior. So 58.35, 36 will do. So we have the final answer as well. Arriba. Okay? Any question regarding problem number 5? Okay? Iwanan ko si number 4. So iwanan ko si number 4. So let us try number 5. So kung kanina, nakita natin ang behavior ng pure R, pure L, pure C. How about if we have a combination? So let us consider what will be the behavior of the circuit if we have an RL circuit. Okay, for RL circuit, so for simplicity, we have only series, resistance, and inductance. So we have R, we have L, we have the given source voltage in terms of E, then we have the circulating current. So again, unless otherwise, your voltage is our reference, so that is bar angle or the phase angle is what? 0. So therefore, at this case, in order to solve for the given current, kukunin natin yung total opposition. Kumbaga sa DC natin, total resistance. So dito, total opposition, it is known to be as our impedance. No? Impedance represent the total opposition of our circuit to the flow of alternating current, which is equivalent to the resistance offered by the resistor at saka yung opposition offered by the inductance. Since alam natin, yung ating resistance is real number. Kapag pinlat natin, yung ating resistance is real number, so ibig sabihin na kay, siya, no? X-axis. Ito yung ating R. Now, alam naman natin that the inductive reactance, that is at positive J. So, nandito yung ating inductive reactance. So therefore, to get the total opposition, ang tawag natin is the impedance. So ibig sabihin, you may combine resistance and inductance, yun nga lang, in terms of what? Complex number. Kasi alam natin, the x-axis is the axis for real number and the y-axis is the axis of imaginary. So it should be positive j x of L. So that should be the impedance. Ngayon, pag kinuha natin yung magnitude ng ating impedance, so pwede natin kunin yung resultant value. So using phasor diagram, so we'll have only parallelogram method. So in that case, from the origin, draw a line towards the intersection. So this would be now the impedance of the circuit. Ito ngayon yung ating Z. At ito yung angle ng ating impedance. So let us consider theta sub Z. So kung ang reference natin is voltage, that is also at angle 0. So this would be our voltage. So lumalabas ngayon kapatid by Ohm's law, pag kinuha natin si current, solving for the value of your current, it should be by Ohm's law, that is the voltage. So since alternating quantity tayo, so anong angle ng ating voltage in phasor diagram? That is at 0 since siya yung ating reference. Now, divide natin dun sa ating impedance. Ano magiging angle? So obviously, nasa taas yan. So it should be what? Positive theta sub Z. So therefore, using the rules in dividing complex number, so dividing the complex number, all you have to do, you just divide the magnitude and subtract the corresponding angle. So anong lalabas, no? So ito yung RMS value ng ating current as the ratio in terms of magnitude of voltage and impedance. Ano kanyang magiging angle? Angle of your voltage, that is at what? 0 minus the angle of your impedance. So lumalabas ngayon kapatid, theta of the voltage is at 0. So pwede nating sabihin that the angle of your current, it is equal to the negative angle of your impedance. So ibig sabihin, palagi conjugate. Kung nasa positive yung angle ng ating impedance, negative yung angle ng ating current. Kung nasa negative naman yung angle ng ating impedance, nasa positive yung angle ng ating current. So for RL circuit, nasaan yung current? Ito siya. So this would be the value of our current. At ito ang kanyang angle. So nasaan siya? Negative angle. So lipat ko lang itong R na to. So ito ngayon yung ating theta sub I. So kapag tinrace mo yan in clockwise, this is negative. Pag tinrace mo to counterclockwise, it should be positive. So anong pwede natin sabihin? Sinong nauna? Voltage ba or current? So nauna, nasa taas yung voltage, nasa baba si current. So ibig sabihin, current lags. So at this case, for RL circuit, ito tatandaan natin that current lags the voltage. By what angle? Theta. So theta is greater than 0 but less than 90 degree. So sino yung theta na yon? Your theta is the phase difference. So pag sinabi natin phase difference, that is the angle between your voltage and the angle of your current, which is equal palagi yan sa angle of your impedance. Palagi equal itong phase difference ni voltage at current sa angle ng ating impedance. At ang tawag din natin dito sa phase difference between the voltage and current, ito yung ating power factor angle. Okay? So, yan din yung ating power factor angle. Sino ba yung power factor? Yung ating cosine na tinatawag. So, ibig sabihin, for this RL circuit, for the combination, for combination circuit, you have the combination of resistance and inductance. So, ang importante, alam natin kung paano gamitin itong triangle niya. So, itong triangle na to, ang tawag natin is the impedance triangle. So, kapag nilipat ko dito, yung tinatawag nating impedance triangle, palagi yung impedance triangle na yan, that is always a right triangle. So, lahat ng formula na pwede mong ma-encounter sa AC circuits, kayang-kaya mong balikan using this impedance triangle. Tinawag siyang impedance triangle. So, the angle here is theta sub A. That's the angle of impedance. Since yung kanyang mga sides is the component of your impedance. So, the adjacent or the real component is the resistance and the opposite is the X or the reactance, and this should be our impedance. Kaya by Pythagorean theorem, pwede mong kunin yung magnitude ng impedance. Pwede mong kunin yung angle using tangent function. Kung gusto mong kunin itong reactance na to, using sine function. Kung gusto mong kunin yung value ng R using cosine function. So using this impedance triangle, majority of the formula makikita mo dito. So anong ibig sabihin? So let's say, multiply ko to ng current. Multiply ko to ng current. Multiply ko to ng current. Ano lumalabas na value? Ito ngayon yung voltage drop across R. Ito yung voltage drop across the reactance. At sino ito? Source voltage. So lumalabas ano relation ng voltage drop in every component at saka yung ating total voltage. Ano ulit sila? Pythagorean theorem. Okay? Nakuha ba? Now, kapag minultiply mo naman diyan ng square of current, multiply ko siya ng square of current. So, dapat multiply ko rin ito ng square of current. Now, multiply ko rin ito ng square of current. Ano mga parameters ngayon yan? So, ito naman, yung tinatawag natin, I squared times R. That is the real power. I squared times X, ang tawag natin dyan, reactive. Sir, bakit siya tinawag na reactive? Kasi yung ating ginamit na resistance, sino? Si reactance. Kaya reactive power. And at the same time, that is along y-axis. So, sino ngayon ito? Yung total power. Ano yung total power natin? That is the apparent power. Kaya pag sinabing power factor, power factor PF, generally, it is always equal kanino? Cosine theta. Sino yung theta na yun? This theta, it is always equal kanino? The ratio of your, or that is the angle of your impedance. Kaya kung babalikan mo yung ating power triangle, pag gumamit ka ng cosine, kasi itong power factor angle na to, equal palagi yan sa phase angle ng iyong impedance. Kaya pag ginamit mo power factor as cosine, so pwede kang mag-cosine dito sa ating impedance triangle. Cosine is adjacent over hypotenuse. So lumalabas, this is simply equal to the ratio of resistance over the impedance. Now, tinawag naman siyang power factor kasi nga kapatid, kapag minultiply ko to ng square of current, so square of current times the resistance is the real power. Square of current times impedance, that is the apparent power, which is the ratio of real over the apparent power. Kaya ang tawag natin is power factor. Kaya kapag alam mo itong analysis ng ating impedance triangle, hindi ka na maliligaw dyan. Lahat ng problem dyan sa alternating quantity, lahat yan, makikita mo ang formula using this impedance triangle. So in that case, for problem number 5, again, that is just an objective. The total voltage in the series RL circuit blank the current by an angle of what? So si voltage ang pinag-uusapan. So ibig sabihin, pwede kong i-replace ito. So, unahin ko si voltage. So, lumalabas voltage also equivalent na voltage leads current by theta. Parehas lang yan. Kung nahuli si current, ibig sabihin nauna si voltage. Kaya pwede rin natin siyang sabihin, voltage leads the current by how many? The angle theta, it is greater than 0 but less than 90 degree. At itong phase angle na yan, tandaan mo, always angle of your impedance. Palagi equal sa angle of impedance yan. So obviously, the angle of impedance is from or in between 90 and 0. So kung nauna si voltage, total voltage should what? Leads the current by how many? Angle between 0 to 90. So leads between 0 to 90. Yun lang hinahanap ng ating problem. Ano letter ito? This should be cast time. Okay? Nakuha ba? So that is the behavior kapag ano yan? RL circuit. So ngayon, for RC, ano? Hindi ko na lang i-derive for RC circuit. Ang impedance natin, you have the resistance. Kanina nakita natin that the reactance offered by our impedance or by our capacitance is at negative. So that is negative X sub C. Kaya yung ating impedance triangle, right triangle pa rin, pero pababa lang siya. No? Ilang pinagkaiba. Ayan lang yung ating magiging impedance triangle. Right triangle pa rin yan. Ito pa rin yung angle ng ating impedance. Ito pa rin yung resistance. Ito pa rin yung reactance. At ito pa rin yung impedance. Wala pa rin pinagkaiba. Okay? So the same. Yun nga lang, yung angle ng ating impedance ay nasaan na? Nasa baba. So that is at negative angle. Kaya kapag kinuha mo by Ohm's law, so tataas naman yung ating current. Kaya for purely or for resistance and capacitor, so ito naman ang relation. Your current, ano siya, leads voltage by theta. At parehas pala sila. Ibahin ko ang kulay. At ano ulit si theta? Theta is greater than 0 but less than 90 degree. And this theta, it would be the same, the angle of your impedance. So kaya pag may capacitor, leading. Pag may inductance, lagging. Sino ang leading? Yung current. Kapag meron kang capacitor. So kapag meron kang inductor, sino ang lagging? Si current. Nahuli siya kay voltage. Okay? So ayan yung mga response ng ating mga circuits na usually yan ang ginagamit nating basis for the analysis of the behavior of any corresponding circuits. Okay? So iwan ko yung problem number 5. Let us try number 6. So for number 6, the maximum values of alternating voltage and current are as follows. In a circuit connected to a 50 Hz source supply and the quantities are sinusoidal, the instantaneous values of voltage and current are 283 volts and 10 ampere respectively at time equal to 0, both increasing positively. What is the power factor of the given circuit? So alam na natin si power factor, it is cosine theta. Sino si theta? Theta is the phase difference between voltage and current. So therefore, to solve for this phase factor, kailangan malaman natin ano phase angle ng voltage at current based sa problem. So binanggit ng problem that the maximum value for our voltage that is equivalent to 400 volts, wherein the maximum value for our current that is only 20 ampere. Now let us consider at t equal to 0, we have found out that the instantaneous value of your voltage is 283 volts, wherein the current it is equal to 10 ampere. So what would be the power factor of the given circuit? So, paano ba natin kukunin yung ating phase angle? So, simple lang. So, kunin natin from our general equation for instantaneous value of your voltage, which is equivalent to E sub M sine omega t plus minus of what? Theta sub t. So therefore, using this equation, you have the instantaneous value, which is 283. Kailan yon? At time equal to 0. So you substitute to this value and we have maximum. So makakompute natin ano yung kanyang phase angle. Ha? So same also for the given current. At time equal to 0, you have instantaneous of 10. We have the maximum value. So makukuha natin yung phase angle ng ating current. So solving for the phase angle ng ating voltage, so substitute na lang natin ito. So after we substitute, ano lalabas na value? Ano instantaneous? This problem is 283. Ano maximum? 400. Sine. Ano value ng t at which this instantaneous is computed? That is at time equal to 0. So that is at origin. So at t is 0, substitute here. So this is just 0. Ano na lang natira? So that is only the phase angle. So makukuha natin ngayon that the phase angle of your voltage, it is equivalent to what? 283 over 400. So meron tayong phase angle ng voltage, no? Arc sine of 283 over 400. Oops, naka-radian ako. Dapat naka-degree. Shift, set up, i-degree ko lang yung equal. 45. Sabihin na lang natin 45 degree. Therefore, same idea. Kunin natin yung instantaneous equation for our current. So your current I equal to so after this substitution, ano ang kanyang instantaneous? 10, maximum of 20. Kailan ako sa instantaneous at time equal to 0. So malitira na lang is the value of our phase angle of the current. So you may compute now theta sub I, it is just simply equal to what? Arc sine of 10 over 20, which is equivalent kanina. 30 degree. So parehas silang positive. So sinong nauna dyan? Si voltage ba or si current? So obviously, kung tumakbo yan, kung pares tumakbo, so mas nauna sino? Yung ating voltage. Kasi nasa 45 degree na siya, si current is only at what? 30. So therefore, pwede nating sabihin, the current lags the voltage by how many degree? So that is your phase angle. So the phase angle is theta of voltage minus theta of your current. So equal kanino? 15 degree. So lumalabas, current lags the voltage. Current lags the voltage by how many degree? By 15 degree. So ibig sabihin, by just looking to the phase angle of your current and voltage and by knowing if the current is lagging or leading, so malalaman natin agad if what are the parameters available in the given circuit. So if current lags the voltage at a certain angle, alam natin that the circuit is what? RL circuit. Sir, bakit RL? Kasi alam natin ang behavior ng RL, ito yan. For RL circuit, current lags the voltage by theta. At ang theta na yan, greater than 0 but less than 90. So pagpasok siya dito sa angle na to at current is lagging, automatic, the circuit parameter connected, it is simply RL. Okay? Kaya ibig sabihin ng lagging, alam mo agad kung anong klaseng parameters ang kailangan mo i-analyze. Pag lagging, RL. Pagka leading, RC. So, ibig sabihin, for any given circuit, so dalawa palagi ang kahantungan lang yan. Either RL ba siya or RC circuits. Okay? So, in that case, kuha na natin yung phase angle. So, wala nang problema. You may compute now its corresponding power factor. So that is only cosine of 15 degree. So we have now the final answer. So this is only 0.15 966. So, ano dapat ito? Lagging. Kasi current is lagging. Or this is also equivalent to 96.6% lagging. So, pwede natin express si power factor in terms of percentage or in terms of decimals. So, 96.6 will do anong letter? That should be Dog's style. Okay, ko ba? Any question regarding problem number 6 now, how to get the corresponding power factor based on the relation of your voltage and current. So, if current lags, meron kang RL. If current leads, you have what? RC circuit. Okay, so iwan ko si number 6. So let us try number 7. A series RL circuit has inductance of 0.02 Henry and an impedance of 17.85. So kunin ko na lang yung ating equivalent circuit here, no? So we have RL circuit. So let us consider now we have the RL circuit and we have the inductance of our coil. It is equivalent to 0.02 Henry, pero wala tayong resistance. So you have the magnitude of the impedance. Pag kinuha natin yung magnitude of the impedance, Z, using our impedance triangle, so by Pythagorean theorem, that is simply equal to R squared plus what? X of L is squared, which is based on problem that is 17.85 ohms. Binanggit, when sinusoidal voltage is applied, the current lags the voltage by 63.5 degree. So lumalabas kapatid that the phase angle between the voltage and current, it is equal kanino? 63.5. At alam natin, this phase angle between voltage and current, that is the angle of your impedance. Kaya kung babalikan natin yung ating impedance triangle, madali na nating masosolve yung kanyang angular velocity. Okay? So, let's say that would be our impedance triangle. Meron na tayong value rito. This is the angle of your impedance. This should be our X of L. This is the resistance. And this is the magnitude of your impedance by Pythagorean theorem. So, saan natin makakita yung ating omega? Alam natin, inductive reactance, it is always equal to omega L. So therefore, using this impedance triangle, gamit ako ng trigonometric function sine. So if I'm going to use sine theta sub c, ano nga si sine? Opposite over hypotenuse. Sinong opposite natin? That is the inductive reactance. Sino adjacent or hypotenuse? That is the impedance. At alam natin, this is equal to omega L over kanino? Z. May magnitude tayo ng impedance. Meron tayong inductance. So, wala nang problema. We have now the omega. So, solving for the angular velocity, it should be equal to the impedance. I-divide natin kay inductance. Multiply na lang kanino. Sine theta sub c. Wala. Magnitude of the impedance, 17.85 over the inductance of 0.02. Sine 63.5. So, meron na tayo angular velocity. Ano lumabas? So, you have 17.85 divided by the inductance of 0.02. Then, you just sign 63.5. So, ito na yung ating angular velocity, which is equivalent to 798.73. Anong unit yan? It should be measured in radian per second. So that should be the answer. So based on the following choices, you may consider that is what? Dog's style. Okay, nakuha ba? Any question regarding problem number 7. So yun lang siya kapatid. So using impedance triangle, madali nating nakuha yung ating angular velocity. So take note, the phase angle or the phase difference between the voltage and current always represent the angle of your impedance. Kaya pwede na natin gamitin talaga impedance triangle. Okay, so iwanan ko si problem number 7. Let us try number 8. In a given circuit, the instantaneous voltage and current are given by the equation. What is the average power? So for problem number 8, hindi binanggit kung anong circuit parameters meron tayo. Ang binigay lang, the equation of our voltage, which is equivalent kanino? 200 sine 377t. So volts. So by inspection, we may clearly identify that its phase angle is at what? 0 degrees. So siya yung reference natin. Now, the circulating current in the given circuit has an equation of what? 10 sine 377t minus what? 60 degree ampere. So we have clearly identified that the phase angle of your current is at what? Negative 60. So by merely looking to their phase angle, makukuha natin that the phase angle between this voltage and current in this circuit, lumalabas, that is at what? 60. Okay? So obviously, the voltage is at 0, wherein the current is at what? Negative 60. So pwede nating sabihin ulit ngayon dyan that current, ano siya? Nahuli. Kasi nasa 0 na. No? Nasa 0, pa-positive na si voltage. Yung ating current ay nasa negative 60 pa. So at this case, current lags voltage by how many degree? 60. So pasok pa rin siya from 0 to 90 if current lags. So therefore, by just merely comparing the phase angle, alam natin na ang circuit na to is what? RL circuit. Okay? So RL circuit. So ano hinahanap ng problem? No? So ito ngayon yung ating circuit. So we have the equivalent circuit, RL. So based on the phase angle, nalaman natin na RL circuit yan. So sino hinahanap? What would be the corresponding power? So sinong power? So based on the given unit, that is what? Real power. So ano na ba yung tawag dyan sa real power? So tinawag siyang average, tinatawag din niyang RMS, tinatawag din niyang effective, tinatawag din siyang true, tinatawag din siyang active. Tawag din natin dyan is real. So yan yung mga different term that represent the power measured in watts. At ang symbol na ginagamit, that is our P. So ano ang kanyang formula? So kaya nga tinawag natin siyang real. So kanina sa DC, alam natin power is voltage multiplied kanino? Current. Yun nga lang, sa DC, yung current natin is purely magnitude. Eh ngayon, meron na tayong component. So kung ipa-plot natin yung ating current, kapatid, so voltage is at 0. So once the voltage at 0, so your current, so nasan si current? Andito siya. No? So this would be the phase angle between the two. So since yung ating current, no, that is alternating quantity vector, so pwede nating sabihin that the given current, there are always two possible component. So kapag kinuha natin yung component na yan, meron tayong real component o the horizontal component. Ito yung kanyang real component, let us say I sub x. Ito yung kanyang imaginary component, that is I sa Y. Now, ano ba yung power? Now, power is the rate of doing work. So, pag sinabi nating work, so usually sa physics, no? So that is the force multiplied the distance. So kapag kinuha mo yung force at distance, kailangan they have the same direction. So kung applied force mo is horizontal, syempre the movement of the given body is also horizontal. So kailangan yung force at distance should be in the same direction. So that is also the same with here. So kung gusto natin kunin yung power, so kailangan kukunin natin yung product ng voltage and current wherein they have the same direction. Kaya pagdating dito, kukunin natin yung component ng current that is same with the direction of your voltage. Sino yon? The X component. Eh alam natin, the X component, ang tawag natin dyan is the real component. Bakit siya real component? Kasi that is along real axis. So yung ating Y component, ito yung tinatawag nating reactive component since nasaan siya? Reactive axis. Kaya kapag kinuha natin itong I sub X na to kapatid, it should be equal whatever the value of your current, i-multiplied mo kanino? Cosine theta. Kaya kapag sinubstitute natin dyan, you have only E times I multiplied kanino? Cosine theta. So that is the formula for your real power. So nadagdagan lang tayo ng cosine theta kasi kailangan natin kay current yung kanyang real component, which is also the same as the power absorbed by our resistance. I squared times R. Parehas lang din yan. So that would be our real power, which is also known as what? The apparent, apparent, right? That is the average, RMS, effective, true, active, and real. Eh sir, ano naman po ang tawag kung i-consider natin yung Y component? So at this case, kapag kinuha natin yung Y component, ang tawag naman natin sa kanya is the reactive component. Ang symbol is Q. So that is the product of voltage multiplied the reactive component of this given current. Ano reactive component of current? So that is Y component, whatever the current, multiplied mo kanino? Sine theta. Kaya ito lalabas, the reactive component is EI multiplied kanino? Sine theta. Sir, anong unit nito? This is watts. Anong unit na reactive? So ang unit nito, that is measured in terms of bar. So bakit siya bar? So this is also the same as the power absorbed by the reactance, which is measured in bar. So bakit siya bar? So E is for voltage, B, I is for ampere. So itong sine theta, since this is the reactive component of your current, kaya R is reactive, and which is also considered that the value of your sine theta, ito yung tinatawag naman nating reactive factor. So tinawag siyang reactive factor, RF, since that is the ratio of what? Reactive power over kanino? Apparent power. So that would be the real power and the apparent power. Now, if you try, or the reactive power, if you try to combine these two given power, ang tawag natin doon, the total power in AC, it is known to be as what? Apparent power, wherein ang symbol is what? S. So the apparent power or the total power or the complex power kung tawagin, it is the combination of your what? Real power at saka reactive power. Ang reactive power, pwede siyang positive, pwede siyang negative. Kailan siya positive, kailan siya negative. It always depend kung anong equation ng apparent power ang ginamit natin. So you may compute directly the apparent power, that is the voltage multiplied kanino? Current. Kaya tinawag natin siyang complex power kasi you have to multiply the complex form of your voltage and current. So most of the time, ang ginagawa dyan, meron tayong tinatawag na current conjugate. Ano ibig sabihin ng current conjugate? So kung yung angle ng ating current is nasa negative, pag kinonjugate mo, sa positive siya. Or simply, baguhin mo lang yung sign of its direction. So, pag gumamit ka ng voltage times current conjugate, kaya tinawag siyang complex form, pwede mong ilabas yan in rectangular form as the real and the reactive. So, ito lang ang tatandaan natin. Kapag current conjugate ka, this positive represent inductive. Inductive yung ating circuit. Ibig sabihin, parang meron tayong RL circuit. Now, pag negative yan, meron kang capacitive. So, parang meron lang tayong RC circuit. Now, pwede rin naman ma-encounter ng apparent power, you may also compute it, no, the complex power as voltage conjugate naman. No, pwede rin natin i-conjugate yung voltage. So, kapag si voltage ang kinonjugate mo, kapatid, siya naman ang binago mo ng sign. So, dapat alam natin kung ano ibig sabihin ng negative. So, positive, capacitive kapag voltage conjugate. Pag negative ang lumabas, that should be inductive. So, yun ang pinagkaiba ng positive at negative reactive. So, depende kung paano mo kinompute yung apparent power. Voltage conjugate ba or current conjugate? Now, baka tanongin niyo, sir, ano po bang reference? Both current conjugate or voltage conjugate? So, wala namang problema. Wala namang default setting na palagi current conjugate or voltage conjugate ang gagamitin. So, wala problema kung sinong ginamit mo dyan. Dapat lang consistent ka. So, kung akong tatanungin ninyo, nasanay na ako dito sa voltage conjugate times current. Sir, bakit? Kasi most of the time, yung ating voltage, siya ang reference na kay angle 0. Tama ba? So, i-conjugate ko man ng 0, is still what? 0. So, walang magbabago. Makalimutan ko mag-conjugate, hindi magbabago ito. So, alam ko agad na kapag positive, yung reactive, capacitive. Pag negative, inductive. Eh, alam natin, kapag capacitive, ano ang current? Leading, di ba? Kapag capacitive yan, RC. Anong current? Leading. So, kapag ka-leading, dapat yung angle is nasaan? Positive. Pagka inductive, anong current? Lagging. So, dapat ang kanyang sign, it should be what? Negative. Kaya doon ako. Negative is lagging, positive is leading. Alam natin na lagging yan pag inductive. Leading yan pagka positive. Okay? Nako ba? So those are the different power na pwede nating encounter pagdating sa AC. Unlike kay DC, iisang power lang, real power. Sa AC, meron tayong reactive power, that is the power dissipated in the reactance of the circuit, and the apparent power o yung tinatawag nating complex power that represent the apparent power consumed by the entire circuit or by the entire load, which is the combination of real at saka yung ating reactive power. So kapag binanggit na average power, we are referring to real power. Pag hindi binanggit kung sinong power yan, automatic, ang assumption, it is the real power. So in that case, wala na tayong problema. Alam na natin that the phase angle between voltage and current is what? 60. Kakailanganin na lang natin, sino? The RMS value. Meron naman tayong maximum. Kaya pwede na natin kunin that the average or the real power consumed by this given circuit, RMS value of voltage given sa atin is maximum, make it RMS, divide natin na square root of 2. Multiplied RMS value of current, maximum ang given, then make it RMS, divide by square root of 2. Multiplied cosine. Ano phase angle? We have already computed 60. So meron tayong final answer. 100 times 10, square root. So that is 2 na lang. Multiplied by cosine, 60. So meron tayong final answer that the average or the real power in the given circuit, it is only 500 watts. Pero ba? Ayun, eksakto. Anong letter yan? So this should be valid. Any question regarding problem number 8? Now, how to solve for the different power in AC? So meron tayong tatlo. Resistance or the real power, that is the power absorbed by the resistive or the resistance of the circuit. Reactive power, that is the power dissipated in the reactance of the circuit. And you have the apparent power that represent the complex or the total power that represent or the total power consumed by the load or consumed by the given circuit, which is the combination of real and reactive power. Okay, ba? So, any questions kapatid before tayo magmerienda? Before tayo mag-coffee break for 15 minutes? Any questions? May tanong ba? Any clarification so far? So, kung papansin niyo, hindi tayo lalayo sa Ohm's Law. So, still, this is only under Ohm's Law. So, idagdag nyo lang kay Ohm's Law. Kanina kay Ohm's Law, circle. No? So, ngayon, idagdag nyo lang yung relation ng ating right triangle. So, pagka alam mo kung paano gamitin itong impedance triangle, no more problem for the different formula dyan sa ating AC circuit. Single phase man yan or three phase, hindi tayo lalayo kay Ohm's Law at saka dito sa right triangle. Okay, so let us have a short break, 15 minutes. After 15 minutes, resume natin yung discussion. Okay, so let us continue. So let us try for problem number 9. So for problem number 9, we have series RLC. So series RLC consists of resistance of 20 ohm, inductance of 0.2 Henry, and a known capacitance. So what is the value of capacitance if the circuit has a leading angle of what? 45 degree at 60 degree, or at 60 hertz. So let us consider for our series RLC. So we have the resistance, inductance, and the capacitance. So given that resistance is 20 ohms, inductance is only 0.2 Henry, and we have a known capacitance connected across our source voltage E. So let us consider for simplicity that the voltage is our reference. So phase angle of this voltage, that is what? At 0. So binanggit ng problem, what is the value of capacitance wherein the circuit has a leading angle of what? 45 degree. So leading angle of 45 degree, ibig sabihin, no, yung phase angle between current and voltage, so that is what? 45 degree. So leading angle, isa lang ibig sabihin yan, no? The current leads the voltage by 45 degree. So itong 45 degree na to, that is the angle or the phase angle. At alam natin, this is always equal to the angle of our impedance. So ano ibig sabihin? So pag sinimplify pala natin itong circuit na to, although we have series RL, since the current leads the voltage by E, parang lumalabas, meron lang tayo equivalent RC. No? Not necessary RC lang siya. Ibig lang sabihin, ang behavior niya para siyang RC. So paano natin kukunin yung kanyang capacitance? So kapag kinuha natin yung ating total impedance, so the total impedance, that is the resistance plus you have inductive reactance, then you have the negative capacitive reactance. So therefore, pag sinimplified natin yan, you have R plus minus J, sabihin natin, that is X of L minus 1, X of C. And let us consider that X is equal to X of L minus 1, X of C. So meron kang sign na positive at saka negative. So ano ibig sabihin? So kapag positive yung ating reactance, pag positive yung ating net reactance, tawag na dito is net reactance. So kapag positive yung ating net reactance, ito, ibig sabihin, ang behavior niya para kang merong RL. Okay? Lagging, more inductive. So kapag negative ang lumabas dyan, ang kanyang behavior para ka lang merong RC. So since at this case, lumalabas na yung ating circuit since the current leads by 45 degree, so therefore the behavior of your circuit, it should be what? No? It should be at RC circuit. Kaya yung ating reactance, it should be what? Negative reactance. No? Kaya kapag kinuha natin yung ating impedance triangle dyan, So ito yung ating magiging impedance triangle. Since RC siya, so yung ating impedance triangle ay nasa baba. Okay, so this would be the resistance. Ito yung ating reactance. At ito yung magnitude ng impedance. And this angle is our theta sub C. So since leading ang current, so yung ating impedance nasa baba, kaya alam na natin, this given angle, that is the angle of your impedance. No? So that is our theta sub Z. So that is 45. So kung 45 yan, kapatid, ibig sabihin na itong right triangle natin, so meron kang isosceles right triangle. Kasi yung angle ng ating impedance, that is equal kanino? 45. So, ibig sabihin ng isosceles right triangle, whatever the value of your resistance, it is equivalent to the magnitude of your reactance. Since leading yan, yung ating reactance, net reactance, it should be negative. So, lumalabas that the net reactance here in terms of magnitude, that is what? 20. Kasi yung ating resistance, that is also what? 20, no? In terms of magnitude. Ngayon, kapag kinuha natin yung ating complex number o yung ating impedance, so anong resistance? 20. Ano reactance? Negative J20. Nakuha? Kasi yung ating current leads the voltage by 45. So its behavior para siyang RC. So in that case, yung ating net reactance, that is negative X, which is equal kanino? X sub L minus what? X sub C. So therefore, makukuha natin ngayon that the X sub C, it should be equal na kanino? X sub L plus the net reactance X. No? So yung negative na to, kinonsider na natin, nilipat natin doon. Kaya ano siya? Positive. So your X sub C, it is X sub L plus what? Net reactance. Nakuha ba? So if the behavior is what? RC circuit. So pag RL circuit siya, so that is simply net reactance minus or X sub L minus X. Okay? Nakuha ba? So therefore, your capacitive reactance, it is always equal kanina 1 over omega C. So, nandun na yung hinahanap natin capacitance. Anong binigay na frequency? So, given sa atin, that is at what? 60 Hz. So, no problem dun sa ating angular velocity. So, siguro, sir, wala pa po tayong X sub L. Ano ba si X sub L? This is what? Omega L. Meron tayong inductance of what? 0.2. Anong net reactance natin? Since the angle of your impedance, it is equal to the phase angle or the angle between voltage and current, which is 45. So, ibig sabihin, meron tayong isosceles right triangle din. So, ang magnitude ng net reactance, it is equal to the resistance. Kaya nakuha natin, this net reactance, it is equal kanino? 20. Kasi, isosceles right triangle ito. Kasi 45. So, kung 45 ito, alam natin, this is also 45. Kaya ito is what? Isosceles. So, in that case, wala nang problema. Makukuha natin ngayon that the value of our capacitance it is just simply equal to 1 over omega quantity X sub L plus what? Net reactance. O, yun ay ating capacitance needed. So therefore, pwede ko nang diretsuhin. Lagay ko rito, solving now for the capacitance. 1, ano frequency? 60. No, 60 multiplied by 2 pi, that is 377. So meron tayong 377 multiplied, X sub L is omega ulit, 377. Ano inductance? 0.2. Net reactance, i-add natin as 20. So meron na tayong capacitance needed. So ano lumabas? You have 1 over 377 times 377 times 0.2 plus 20. So the capacitance would be 27.8 microfarad. So that would be the required capacitance so that the given circuit will become RC circuit, or ibig sabihin, ang behavior niya para siyang simple RC circuit. No? So para siyang RC circuit kasi pag kinuha natin yung net reactance nito, negative. Pag negative yung reactance, it represent what? Capacitive reactance. Yun lang ibig sabihin nun. So anong letter, kapatid? 27.8. So this should be baliktaran. Pero kung sinabi ng problem na laging yan, no? Kung laging, so dapat positive ito. So lalabas positive reactance. So kapag laging positive reactance, X sub L minus X sub C. So kapag kinuha natin si X sub C, lalabas X sub L minus the net reactance, and that is your capacitive reactance. Nakuha ba? Any question regarding problem number 9? Leading, pagka leading yung behavior, para kang may simple RC circuit. Pagka laging ang behavior, para kang merong RL circuit. So number 10, hinahanap lang yung ating conductance. So sino nga ba si conductance? No, conductance, that is the reciprocal of our resistance. However, kung babalikan natin, no, for conductance G, which is by the definition, conductance is the reciprocal of resistance. But take note, this formula is applicable only kapag meron tayo purely resistive. Ibig sabihin, sa circuit, resistance lang ang nakikita mo. Wala tayong ibang component. So, doon lang applicable yung reciprocal na resistance. Ngayon, based on the given circuit, based on the circuit diagram or impedance, yung ating circuit, it is actually what? Series RL. Tama? So, you have series RL wherein the impedance, according to problem, that is what? 6 plus J8. So, ano hinahanap? What would be the corresponding conductance? So, paano natin ngayon kukunin yung ating conductance? So, kapag kinuha natin si conductance for combination circuit, meron kang RL, RC. So, to get the conductance, kukunin natin ngayon yung tinatawag natin admittance. No? This is the admittance. Sino nga ba si admittance? No? So admittance, mathematically, that is the reciprocal of your impedance. So admittance, it is just 1 over Z, ano si Z, R plus or minus JX, no? Para general. So para makuha natin yung admittance na yan, so ang gagawin natin, i-rationalize mo yung ating circuit. So paano i-rationalize yan? I-multiply mo yung buong equation sa kanyang conjugate. So, pag sinabi natin i-rationalize, kailangan wala tayong imaginary dyan sa baba. So, you have to rationalize this given equation. So, anong lalabas dyan? So, at that case, pag sinimplify natin admittance, so pag samasamahin natin yung real number R over R squared plus net reactance squared, so ito, minus or plus, okay? You have J reactance over kanino? R squared plus reactance squared. So lumalabas, yung ating admittance, kaparehas ng impedance, meron siyang two component. Ano yung component ng admittance? That would be H conductance and you have the susceptance. So yun ang component ng admittance. Meron kang conductance at saka susceptance. So by comparison, lumalabas ang general formula for your conductance, it is the resistance over R squared plus X squared. Kaya nga kung pure R lang tayo, kung pure R, wala kang reactance. So takpan mo to, cancel mo to. So ano matitira, no? So pag pure R, X is 0, R over R squared, babalik tayo kanina, 1 over R. Okay? And the tawag natin is the susceptance. Ito naman yung ating susceptance. Okay? So, ibig sabihin, conductance, the conductance, it is the reciprocal of resistance, which is R over what? R squared plus whatever the reactance is squared. And solving for a particular susceptance, which is the reciprocal of reactance, that is also R squared plus what? X squared. So yan yung general formula in solving for your resistance or for your conductance and susceptance. So kung gusto mong i-what. Ngayon, dahil alam naman natin, admittance is a reciprocal of your impedance, o pwede mong computin yan using your complex number. 1 over 6 plus GA. Then express the answer in rectangular form. Yun na rin yun. 1 over 6 plus 8i. Oh, hindi ako naka-complex. 1 over 6 plus 8i. O, tsaka may equal rectangular form mo. So, meron tayong real component which is 0.06. Meron tayong imaginary component which is 0.08. So, anong unit? Mho or Siemens. So, the real component represent the conductance. The imaginary component represent the susceptance. So, kung gusto mo i-counter check, it would be the same as this given equation. Ano yung ating resistance? 6. So, therefore, meron kong 6 squared plus 8 squared. So, that is also 0.06. So, ito, the same lang dyan. So, gusto mabilisan using this complex number. So, ilang hinahanap ng ating problem. Anong letter ito? So, the conductance of this given circuit, it should be 0.06. Okay, kuha ba? Any question regarding problem number 10? So, iwan ko si number 10. Let us try number 11. No? For number 11, a feeder supply to loads. So, one is 50 ampere at 50% power factor, and the other is 150 ampere at unity power factor. So, based on the value of current in every corresponding load, so magkakaiba yan. So, ibig sabihin, meron lang tayong parallel. Kasi alam natin, kung series yan, iisang current. And since magkaiba yung current, so we have parallel loads. So, anong klaseng load meron tayo? So, kapag inanalyze natin in terms of the power factor, sir, hindi po binanggit kung ano yung power factor, leading ba or lagging. So, ganito palagi ang assumption. Kapag walang binanggit kung anong klaseng power factor yan, let's say itong si 50%, hindi binanggit kung leading or lagging yan. So, palagi ang assumption, it is what? Lagging. Sir, bakit po lagging? Kasi majority naman, reality, ang load natin ay mga motor loads. Okay? Electric fan, kung sa commercial, no? Kung sa bahay, o meron kang fluorescent bulb, so that is also may inductive yan. Yung mga different appliances mo, so inductive din yon. Sa mga commercial, so malalaking motor. So palagi inductive. Kaya pagka walang binanggit, automatic ang assumption natin is inductive. So meron tayong two loads connected in parallel, no, across the common source. So yung first load, 50% power factor, which is assumed to be lagging. So kung lagging yan, alam natin, current lags, anong behavior? RL circuit. Now, yung second load, anong klaseng load meron tayo? Since power factor is unity. So pag sinabing unity, that is 1. Power factor, unity. So, cosine theta is 1. Kailan ba magiging 1 yung ating cosine? If the angle theta is 0. Ano ibig sabihin? The phase difference between voltage and current is 0. So, ano ibig sabihin nun? They are what? In phase. So, kung in phase sila, ano ang ating circuit parameter? So, that should be resistance. No? Kaya yung ating first load, since power factor is 50%, which is assumed to be lagging, so pwede natin i-consider that is what? RL circuit. Now, yung second load connected in parallel, dahil unity power factor, so purely resistive lang. So, ayan yung ating dalawang loads. So, kung kukunin natin yung current dito, so the magnitude of current here, that is I1, and the magnitude of current here, that is what? I sub 2, which is connected across an AC source. Okay, so let us consider that would be our source voltage E. Siya ulit gawin nating reference with angle that is at what? 0. And we have now the corresponding current, I total. Now, based on problem, the magnitude of our current I1, this is 50 ampere. Now, the power factor of the first load, that is 0.5 lagging. Now, the second load, 150 ampere, and its power factor sub 2, that is what? Unity. So, since we have parallel, so alam natin, for parallel circuit, current is always additive. I total, it should be equal to I1 plus I sub 2. But take note, ang pinag-uusapan natin dito is vector, so you have to add them vectorially. Ibig sabihin, isasama mo yung kanilang direction. Sir, saan natin kukunin yung direction? Kung babalikan mo, power factor angle theta, it is the phase angle between voltage and what? Current. Now, this is the value of your angle, arc cosine of the power factor. Kasi cosine theta is the power factor. Tama? So, kung kukunin ko itong phase angle, phase difference, that is arc cosine of what? Power factor. So now, if we set your voltage as reference, so at voltage is 0, anong makikita natin? So, pwede kong tanggalin ito. Anong lalabas? No? So that the value of your phase angle or phase difference, it is now the negative angle of your current. So ibig sabihin, kung laging yan, no, kung ang voltage at 0, laging nasan dapat si current? Nasa negative. Kung leading yan, nasan dapat ang voltage? Nasan dapat ang current? Nasa positive. So lumalabas, ibig lang sabihin yan, theta of your voltage is at 0. So the power factor angle or the phase angle of your current, it is always equal to plus minus arc cosine of your what? Power factor. So kailan siya positive? Positive yung angle ni current kung ang power factor is ano? Leading. Negative ang angle ni current kung ang power factor is what? Lagging. Ngayon, tulad dito, hindi binanggit kung anong power factor to, leading or lagging. So palagi ang assumption that is lagging kasi majority of the loads are what? Motor loads. So may mga coil sa inductive load. Nakuha ba? So therefore, using their power factor, makukuha natin yung kanilang angle. At ang magnitude nila, that is already given. So in that case, makukuha natin ngayon yung ating total current. So lumalabas that the total current for this given circuit I sub T, it should be equal. Ano magnitude ni I1? 50. Ano magiging angle? So use your complex number. So since power factor, unless otherwise, it is assumed lagging. So pagka lagging yan, dapat negative. Anong angle? Arc cosine of power factor. Ano yung power factor niya? 0.5. So that is your I1. I2, 150 angle. So since unity, angle is what? 0. Walang leading or walang lagging. So the angle, it is just what? 0. Okay? So nakuha ba? So therefore, ilabas mo na lang ang sagot sa polar form. So kapag lumabas na positive, leading. Pag lumabas na negative, lagging. So since wala tayong capacitance dyan, kaya malabo magkaroon ng leading. So lagging yan kasi meron tayong inductive. So dapat ang lalabas na angle dito, negative. Ang kailangan lang ng problem, itong magnitude. So therefore, using your complex number, 50 negative kasi lagging yung ating power factor by first load. So kunin mo arc cosine of 0.5. Then i-add mo na lang 150 since unity per angle 0. Then express the answer in polar form. Equal mo. So ito na yung final answer natin. So the total current, you have 180.3 angle of negative 13.9 degrees ampere. So ito ngayon yung hinahanap ng ating problem, total current. So therefore, in case hanapin sa inyo yung overall power factor, the overall power factor of the circuit, so that should be cosine angle of your voltage minus the angle of your total current. So since angle of voltage at 0, so diretso ka na. Cosine of what? 13.9, it would serve as the overall power factor in case hanapin ng problem. So cosine of 13.9, so it should be 0.97. Leading or lagging? Lagging yan. Since lumabas na sign niya is negative. So dito, ang hinahanap lang is the magnitude. So you have 180 cuts time. Okay po ba? And question regarding problem number 11. So you want to let us try number 12. So for number 12, again, we have inductive reactance of 8 ohm is connected in parallel with capacitive reactance of 18 ohms. The combination is then connected in series with a variable resistance. For what value of resistance will the power factor be? 50%. So kung kukunin natin yung equivalent circuit ng problem, so we have variable resistance R, then we have the inductance parallel with capacitive reactance. So hindi natin alam kung ano value itong R, but this inductive reactance, it should be positive 8. Then capacitive reactance, it should be negative 18. So hinahanap ng problem, what would be the value of R at which the overall power factor of the circuit will become 0.5. Okay? So equivalent to 0.5. So let us consider again that the angle of our voltage is at what? 0. So paano natin kukunin yung resistance na yan? So at this case, pwede muna nating i-simplify itong circuit na to. Okay? So pwede nating i-simplify dyan into a combination of resistance and tsaka net reactance. So si net reactance na yon, Rx, or sabihin na lang natin, pwede nating i-simplify dyan, and the simplification, pwede siya either after we simplified, lalabas siyang RL, or possible, pag sinimplified natin siya, pwede siyang maging RC. Paano natin malalaman na RL or RC yan? So simple lang. RL yan kapag yung ating impedance, ang net reactance is positive. RC yan kapag net reactance natin is negative. So paano gagawin? So since nakaparallel, pwede naman natin i-combine ulit ito. Pwede natin i-parallel to, di ba? So kapag pinarallel natin yan, since reactance yan, ito ngayon yung ating magiging net reactance. So nakadepende sa magiging sign ng ating net reactance kung ano magiging behavior nitong circuit na to. Kapag pinarallel natin yan at lumabas na net reactance is positive, ang behavior RL siya. Kapag lumabas na value ng ating net reactance is negative, so parang meron tayong RC. So therefore, kunin lang natin yung ating net reactance. Solving for the net reactance, so parallel combination. So ipaparallel lang natin. So J8 raised to negative 1 plus negative J18 raised to negative 1. So that is parallel operation raised to negative 1. So parallel tayo nagparallel ng resistance. Yun ang reactance. So you have to include their corresponding imaginary number or the direction. So therefore, meron tayong 8i inverse plus negative 18i inverse close quantity inverse at saka natin equal. So we have now the net reactance. Ano lumabas na net reactance? So positive 14.4. So ibig sabihin, the given circuit is what? RL. Kaya pag kinuha natin yung kanyang impedance, So the impedance, that is the unknown R plus J X, wherein the value of X, that is only 14.4. So in that case, pwede natin gamitin ngayon yung ating impedance triangle. So kung babalikan natin yung impedance triangle, right triangle lang ulit tayo. Okay? So this would be the magnitude of our net reactance. Ano na-compute natin sa net reactance? Its magnitude 14.4. Hindi natin alam kung ano resistance. You have the impedance. Now, anong angle ito? Theta sub Z. So, based doon sa ating power factor, alam natin power factor, it is always cosine theta. At alam natin, kapatid, this theta, it is always equal to the angle of your impedance. No? Kinuha na natin kanina yan. That the power factor angle, it is always equal to the power factor or the angle of your impedance. So lumalabas kapag kinuha natin si theta sub C, that is just simply equivalent to arc cosine of what? Power factor. So meron na tayo ngayong angle. So solving for the value of R using this impedance triangle, gamit ako ng tangent function. The tangent of the angle of impedance, it is equal kanino? X over R. So in that case, kuha na natin yung resistance. Ano net reactance? 14.14. I-divide natin tangent, ano angle of your impedance? That is equivalent to power factor angle. So tangent of arc cosine of 0.5. Meron na tayong required resistance so that the power factor will become 0.5. So you have 14.14, divide na lang natin kay tangent of shift, arc cosine of the power factor, which is 0.5, equal. So the required resistance should be 8.313 anong unit. So that is in terms of ohms. Pwede na natin i-rounded off yung third digit. Gawin na lang natin ito ng 4. 8.314 ohms. So that would be our final answer. Anong letter ito, kapatid? Sorry, Karina. Nakuha ba? Any question regarding problem number 12? Ano ba kay number 12, kapatid? So, gano'n lang, no? So, kung papasin mo, bumalik lang tayo dun sa impedance triangle. Okay, so, iwanan ko na si number 12. Let us try number 13. So, for number 13, what capacitance must be placed in series with an impedance of 0.0, or inductance rather, of 0.05 Henry so that at 100 Hertz, the impedance become equal to ohmic resistance. So, sino yan, no? If the impedance or if the behavior of the given circuit, it is just purely resistive or equivalent to ohmic behavior, ang tawag natin doon is what? Resonance. Okay, so a circuit phenomenon wherein the behavior of your circuit behave as what? Purely resistive. So kung i-general natin, let's say we have series RL circuit. Sa yung RL ko kanina, hindi ko na i-draw. Ito. So let's say we have a series RLC. Tanggalin ko muna itong mga value, which is connected across an AC source. And let us consider reference is your voltage. So, ano magiging behavior ng ating circuit at resonance? So, alam natin yung impedance na yan, that is simply R plus or minus JX, wherein X is the net reactance, which is equivalent to XL minus 1, X sub C. Now, pag sinabi natin resonance, So at resonance, lumalabas that the circuit behave as purely resistive. So ibig sabihin, kapag kinuha natin yung total impedance ng ating circuit, para lang siyang resistance. That is at resonance. No? The circuit behave as purely resistive. So ibig sabihin, para yung resistance or impedance natin will become equal to the resistance of the circuit for series or LC, dapat yung ating net reactance is what? Zero. So, kailan magsisiro yung net reactance? Net reactance is zero kapag ang value ng ating inductive reactance is equal kanino? Capacitive reactance. Kailan ba sila mag-i-equal? Alam natin, inductive reactance is omega times L. At yung ating capacitive reactance is omega times C. So, therefore, kukunin natin yung frequency at which these two are what equal. So kapag kinross multiply natin yan, makikita natin angular velocity is squared times LC is equal to 1. So that is the condition for your resonance. Ano ba itong angular velocity na to? That is our 2, 5F. So, ibig sabihin, yung frequency dyan, that is the frequency at resonance. That is the frequency at which the circuit will operate at what? Resonance. Kaya kapag kinuha mo yung resonance frequency na yan, so pwede natin considered for series resonance, F sub R, it is always equal to 1 over 2 pi square root of what? LC. So that would be our resonance frequency. That is the frequency at which net reactance becomes zero. If net reactance becomes zero, the circuit will behave as purely resistive. So kung purely resistive yan, alam agad natin at purely resistive, the phase angle between voltage and current is what? Zero. Kasi ano sila? In phase. Diba? Kung babalikan natin, at purely resistive, current and voltage are what? In phase. Kaya at resonance, palagi, your current and voltage are in phase. Kaya kapag kinuha natin si current, that is only the source voltage, i-divide natin kay impedance. Sino ba si impedance lang at resonance? E over R. Kaya pagdating sa series resonance, yung ating current, ang term nila dyan is maximum. That is the maximum current. At yung ating impedance during series resonance, it is now minimum. Okay? So that is the idea under series resonance. So therefore, hinahanap ng problem, what should be the value of this capacitance when connected in series with this inductance of 0.05 Henry? What would be the value of this capacitance so that at 100 Hz, the impedance become equal to ohmic resistance. So in that case, yung ating angular velocity or yung ating resonance frequency for this given problem, it is equal to 100 Hz. So what would be our capacitance? Okay, so using this equation or this equation, omega squared LC is equal to 1. Therefore, finding the required capacitance for resonance, it should be 1 over omega is 2 pi times the resonance frequency of 100, quantity squared. Ano yung ating inductance? 0.05. So, meron tayong required capacitance. So, direct substitution na lang pala ito. 1 over 2 shift pi times 100, quantity squared times 0.05. Meron tayong 50.66 microfarad. That should be the answer. 50.66, 50 microfarad will do. So we have, right? Ako ba? So that is at series resonance. Okay? So dalawa lang naman yung ating basic circuit. Isang series at saka isang parallel. So mamaya, balikan natin ano ba behavior kapag parang resonance. Okay, so iwan ko si number 13, that's only series resonance. So number 14, a series circuit with resistance of 20, inductance of 150, and a known capacitance. The circuit supplied with a voltage of 100 sine 377. Find the capacitance at resonance. So number 14, again, we have series circuit. So you have E, you have the inductance or resistance of 20, then inductance of 150 millihenry. Now, the source voltage E, it is given as 100 sine 377t volts. So by inspection, the angle of our voltage, that is what? 0. So na hinahanap, at this given source voltage, what would be the unknown value of your capacitance such that the given circuit again operate at what? Resonance. So anong klaseng circuit? Series circuit. So we are dealing with series resonance. So alam na natin kanina, ayun, nakalagay pa that at series resonance, angular velocity is squared times L times C, again equal to 1. Now, by inspection, 377 represent our angular velocity. Tama ba? So therefore, wala nang problema. Capacitance again, it is equivalent to 1. Ano angular velocity? Based on the equation of your voltage, 377 squared multiply the inductance of 150. So that is 0.15 na lang. No? So yun lang pala yung gawin. 1 over 377 squared times 0.15. So we have now the required capacitance again. So in this case, we have 46.9 microfarad. 46.9, 47 will do. That's time. Right? So that is only under series resonance. So one ko yung series resonance. So let us try for number 15. A coil, pag sinabi natin coil, unless otherwise, ang equivalent circuit niyan is RL, ano? So we have a coil with resistance of 10 Henry and inductance of 0.1 is connected in parallel with capacitor of unknown capacitance. If the total impedance is purely resistive of 100 ohm, determine the value of capacitance. So ngayon, purely resistive pa rin, so resonance. However, ang connection ng ating circuit, that is already at what? Parallel. So meron tayong parallel resonance. So paano naman si parallel? So gawin ko, i-general natin yung equation for parallel resonance. Para at any given situation, applicable itong makuha nating equation, ano? Formula. Okay, so para general yung ating equation, so we have two circuit, isang RL at isang RC which are connected in parallel. So para hindi tayo maligaw, let us designate the resistance in series with your inductance as RL, and this should be our X of L, no? Then the resistance in series, or sabihin na lang natin, this is the inductance na lang. The resistance in series with capacitor, that is RC, then this should be its capacitance. So meron tayong parallel circuit. So therefore, pag kinuha natin ang total impedance niyan by parallel operation, 1 over the total impedance would be equal to 1 over the impedance of RL circuit. Ano impedance ng RL circuit? That is R plus what? JX of L. plus 1 over R minus, this is RL, this is RC, minus what? J X sub C. Okay? So, kapares ng ginawa natin kanina for the admittance, so kukunin din natin yung simplified niya. No? So, pag kinuha natin 1 over the impedance, yun na nga ay tinatawag natin admittance. So, this should be the total admittance. So, in this case, admittance, alam natin, yung real component is the conductance at yung kanyang imaginary component is the susceptance. So, binigay na natin kanina yung formula ng ating conductance. So, lumalabas, the total conductance at this case is the conductance of your RL circuit and the conductance of your RC circuit. So, conductance is directly additive since that is the real component. So, conductance of RL circuit, that is simply RL over kanino. RL is squared plus X sub L is squared. Ito rin yung dinerive natin kaninang formula for the conductance. Ano? Plus, yung conductance ng ating RC circuit. So, it should be RC over what? RC is squared plus what? X sub C is squared. So, ibig sabihin, let's say, wala tayong resistance kay capacitor, purely capacitor. RC is 0. If RC is 0, so tanggalin mo lang ito. Ito ang matitira. Same also, kung wala tayong resistance kay inductance, is 0 mo to, so tanggal ito lang ang matitira. Okay? Kaya general yung ating formula. Meron kang RL and you have also RC. Now, ano yung ating net susceptance? So, this given net susceptance, it should be equal now to the capacitive susceptance minus the inductive susceptance. Ano formula ng ating susceptance? So, alam na natin susceptance, reactance over. So, kapag kinuha mo yung capacitive susceptance, ibig sabihin, capacitive reactance, i-divide mo kanino? Resistance in series with capacitance, at saka yung capacitive reactance. Kapag kinuha mo naman yung ating beta sub L, baguhin mo lang yung subscript. Yan lang naman yung ating magiging equation. Ngayon, pag sinabi natin at resonance, ano behavior? At resonance, the given circuit will behave as what? Purely resistive. So therefore, ang idea at resonance, no? At parallel resonance, dito ko ilagay, at parallel resonance, the net admittance or the total admittance, it is only equal to your conductance. Kasi si conductance, reciprocal ng resistance. So, at ang admittance, it is just the reciprocal of impedance. Nagets ba? Kaya lumalabas, during parallel resonance, your impedance, it is just purely resistive. So, para mag-equal yan, dapat yung ating net susceptance, it should be 0. Para mag-0 yan, dapat yung ating capacitive susceptance equal kanino? Inductive susceptance. So, kailan sila mag-i-equal? So, equal ulit yan based on the resonance frequency. So, hindi ko na i-derive, pero dyan din nanggaling that the resonance frequency for parallel resonance, that is 1 over 2 pi square root of LC, nakamultiply nga lang yan sa square root of CRL squared minus L over CRC squared minus L. So that is the general formula for resonance frequency ng ating parallel resonance. So ibig sabihin, kung wala tayong R, kung walang R, zero mo yan, negative yan lang. So kung wala tayong RL at RC, so 0 ito, negative L over negative L, positive 1, square root of 1. So, ito lang yung matitira natin. So, this is actually the general formula. It's solving for the resonance frequency for parallel circuit. So, this would be the frequency at which these two will become equal. Kaya kapag kinuha natin yung ating impedance, total impedance, which is the reciprocal of your admittance, so lumalabas, it is just simply the reciprocal of our total conductance. Ito yung total conductance. So, therefore, pag kinuha ulit natin ang current, so ganun pa rin. E over kanino? total impedance. So at this case, ang pinagkaiba naman, kapag parallel resonance, the current, it is known to be minimum. Sir, bakit siya minimum? Kasi kung babalikan natin, your admittance at resonance, it is now only conductance. Nawala yung isang component. Kaya yung ating admittance is what? Minimum. So therefore, if admittance is minimum and the reciprocal of admittance is the impedance, so kung minimum si admittance, ano reciprocal ng minimum? So it should be what? Maximum. So yun ang pinagkaiba ng dalawa. Kanina, sa series, minimum ang impedance, maximum si current. Ngayon, sa parallel, maximum ang impedance, minimum yung current. But still, power factor is unity since the phase angle between voltage and current, it is always what? Zero. So ngayon, dito sa ating problem, purely inductor, so RC is just what? Zero. Now, the resistance of the coil, this is 10. Inductance is what? 0.1 Henry. So ano hinahanap? What would be the capacitance of this circuit at which required the magnitude of the total impedance, it is equal kanino? 100 ohms. Now, kung babalikan nyo, kung naalala, the total impedance or the equivalent impedance of the circuit at parallel resonance, it is usually called as what? Dynamic impedance. Now, kung i-derive ko si dynamic impedance, so simple lang. Kapag parallel resonance, palagi mag-i-start tayo sa condition. How to achieve parallel resonance? Net susceptance should be equal kanino? Zero. Okay, so dito natin siya i-derive. Lalabas ito. So in this case, medyo kinakapos na ako ng oras, so hindi ko na siya i-derive. Pero dito lang yan. Ipag-equate mo lang itong dalawa, since wala tayong RC, so tanggal ito. Ang magiging derivation mo, that beta sub C, it is equal to beta sub L. So since for this given problem, RC is just 0, so magkakaroon lang tayo ng 1 over X sub C. Kasi RC is 0, XC over XC squared, 1 over XC, which is equivalent kanino? X sub L over RL squared plus X sub L squared. Alam natin, 1 over XC, it is just simply what? Omega C. At alam natin, the value of your X sub L, it is just simply omega L. So, pwede natin i-cancel out ito at saka yan. So, lumalabas, kapatid, kapag kinuha natin ang ratio ng L over C, it is equal kanino? RL squared plus what? X sub L squared. Saan natin kukunin si RL squared plus X sub L squared? Since binanggit ng problem, the impedance is purely resistive. Ano nga impedance? Impedance is the reciprocal of what? Conductance. At this case, wala tayong RC. So if RC is 0, this should be what? 0. Kaya kapag kinuha mo yung ating impedance, total impedance, reciprocal lang ng ating conductance. Conductance ng ating RL circuit. So, i-reciprocal natin yan. Anong lalabas? This is RL squared plus 1. X sub L squared, i-divide natin kanina RL. So, therefore, pag kinross multiply natin, kita natin, impedance times the RL, that is equal to this value. Kaya si RL squared plus X sub L squared, that is the dynamic impedance multiplied kanino. Kaya nga, kung naalala mo, dynamic impedance for parallel resonance, it is just simply L over R times C. So, yan lang yung formula for problem number 15. Kung dinaretso natin, ayan lang yung solution niya. So, therefore, kuha na natin. Meron tayong impedance, meron tayong inductance, meron tayong resistance. So, directly, we can compute its capacitance. So solving now for the required capacitance for parallel resonance, ano yung given inductance? 0.1. Ano load resistance or resistance in series with inductance 10, and the impedance is 100. So we have now the required capacitance. 0.1 over kanino? 10 times 100 equal. So we have only 100 microfarad. That should be the answer. Meron ba? Ayun, ang letter ito, it should be cast iron. Gets ba? Any question regarding problem number 15? Kuha natin. So that is only under parallel resonance. So for parallel resonance, palagi ang start ng analysis, the condition to achieve parallel resonance. Inductive susceptance should be equal to your capacitive susceptance. Okay, nakuha ba? Any question regarding problem number 15? So try natin si number 16. Mabilis lang naman si number 16. So for number 16, the following data are given for a series RL. So we have series RL which is in parallel with RC circuit. Ano? So si RL nakaparallel kanino? RC. Kunin natin yung mga data. So the resistance in series with inductance, that is the required, hindi natin alam. But the inductive reactance, that is 15 ohms. Resistance in series with capacitance, that is 15. And the capacitive reactance, that is only 25. For what value of the resistance in series with inductance or RL will the circuit be in resonance? So hinahanap lang what is the resistance in series with inductance RL at what condition. Since the two circuits are parallel, so we are dealing with what? Parallel resonance. So for parallel resonance, in order to attain parallel resonance, inductive susceptance should be equal to capacitive susceptance. Ano inductive susceptance? X sub L squared. Capacitive susceptance, XC, RC squared plus 1, X sub C is squared. So lahat ng data available, so this is just direct substitution. So pwede ko nang kunin, cross multiply, so the value of our RL, it should be equal to XC that or X sub L, that is 15 multiplied RC of 15 is squared plus 25 is squared divide by X sub C, which is 25. Sa dulo, minus natin ng 15 squared. So, meron na tayo RL. Square root of 15 times 15 squared plus 25 squared divide by 25 minus 15 squared equal square root of 285 or 16.9 ohms. That should be the answer. 16.9 will do. Anong letter? We have valid. Okay po ba? Any question regarding problem number 16? Okay, so for number 17, we have a load of 5 kVA, 0.65 power factor is supplied 240 volts, 60 hertz. It is desired to raise the power factor to 0.85 lagging using capacitor. So what is the K-bar of the given capacitor? So let us consider for problem number 17. Kapag kinuha natin yung equivalent circuit initially of our load, so we have only inductive load, no? So pag inductive, kunin natin yung kanyang equivalent circuit. So para lang tayo merong series RL. So that will be our inductive load connected to our alternating voltage. So we have the inductive load, no? So we have each equivalent circuit para lang tayo may resistance and inductance. So kapag kinuha natin yung apparent power of this given load, that is considered S sub L, no? So that is 5 kVA, kilovolt ampere, wherein the original power factor of this given load, that is 0.65. So that is lagging, that is connected to our source voltage E. So that is already in terms of RMS value, 240 volts at a given frequency of 60 Hertz. So medyo mababa yung ating power factor kasi usually ang standard no, base sa standard ng ating electric cooperative, so at least 80, no? 80 and above. So we want to correct the power factor from 0.65 to 0.85 in order to avoid penalties given by the electric cooperative. So there are several ways in order to improve the power factor. So we want to improve the operating power factor of the whole circuit from 0.65 to 0.85. So, anong methods ang pwede natin gamitin? So, in this case, based sa problem, in order to increase the power factor, so ang ginamit natin, yung tinatawag natin using capacitor bank. Kapag sinabi natin capacitor bank, so using capacitor bank, that is a purely capacitance connected in parallel with the given load. So, i-connect natin yung ating power factor correction. So, at this case, that is using capacitor bank. At ang connection niyan, palagi, they are just connected in parallel. So, for capacitor bank, let us consider here. Ito yung capacitance ng ating capacitor bank. So, using capacitor bank, what would be the capacitance of our power factor in order to increase the power factor from 0.65 to 0.85. So, kung babalikan lang natin, yung tinatawag natin power factor correction, okay, so there are several ways to improve the power factor. Sir, why do we have to improve the power factor? So kung babalikan natin yung ating power formula, for real power, power is the voltage times the current, cosine theta is the power factor. So kapag kinuha natin yung current, power over the voltage multiplied kanina, power factor. So ano relation ng current at saka ng voltage or ng current at saka ng power factor? So if you try to get the relation of the current in the circuit and the power factor, these two are what? Inversely proportional. So anong ibig sabihin? If we have a lower power factor, what would be the value for your current? So the current increases. So as current increases, so definitely lalaki yung size ng ating conductor. Pag lumaki yung size ng conductor, mas mahal, mas magastos. At the same time, pag mataas ang current, mas mataas ang losses. So yun ang iniiwasan natin. Now, in order to avoid those given scenarios, so kailangan ma-improve natin si power factor. Kasi pag in-improve natin si power factor, which means increasing the power factor will actually decrease the corresponding current. And paano natin improve yung power factor? So there are several ways to solve or to improve the power factor. So one of which is using capacitor bank. Or simply CB. So ang condition yan, for this capacitor bank, it should be loss-free. So, ibig sabihin, sa equivalent circuit, purely capacitance yan, which is connected in parallel. So, paano nga ba nagagawang ma-improve yung ating power factor using this capacitor bank? So, kung babalikan natin yung ating apparent power, so the apparent power, it is always the combination of the real power consumed by the load, that is the real power consumed by this resistance of the load, and the inductive reactance, reactive. So, ang gagamitin ko rito is the voltage conjugate. Kaya yung kanya ang gagamitin ko is negative, so inductive. Kaya ang reactive power consumed by this capacitance, it should be what? Positive. Kaya kung ipa-plot natin yan using the phasor diagram, so makinat ko lang. So kapag pinlat natin using the phasor diagram, yung ating power, yan natin. So i-plot natin una yung ating apparent power of the given load. So real power, so yan ko na lang. So that is real. So nandito tayo sa x-axis. So sabihin natin, ito yung ating real power consumed by the load. Let us say this is what? Is an L. Now, since voltage conjugate tayo, so yung reactive power ng ating load ay nasa baba. So, ang haba niyan, that represent the inductive reactive power consumed by the load. So, kapag kinuha natin si apparent power, so that is just simply the resultant of these two given power. So, ipo-project lang natin si real power. Tsaka si apparent power. Perpendicular. So, meron tayo ngayon tawag natin is the power triangle, which is just similar doon sa ating impedance triangle. Ano? So kung saan nag-meet, draw a line. So eto ngayon yung ating apparent power. Okay? So this would be now the apparent power of the given load. Ito yung kanyang magnitude. So ito ngayon yung ating original power factor angle. So ang aim natin, para tumaas ang power factor, etong angle na to kailangan lumiit. Kasi ang power factor is cosine. Okay? So cosine theta. So as the angle theta decreases, the value of cosine increases. Kasi ang cosine 90 is 0, cosine 0 is 1. Kaya ang aim natin, para tumaas yung power factor natin, kailangan itong angle na to lumiit. So, paano yan liliit? So, by using capacitor bank. So, purely capacitive. So, ang reactive power nito, it should be what? Positive. So, kapag pinlat natin yung kanya reactive power, so nasa taas yan. Andito siya. So that would be the reactive power capacitor bank. So that is at positive. So ang length nito, that would be our Q sub C. Ngayon, anong connection ba? So yung ating load at capacitor bank are just connected in parallel. So tandaan natin, power is always additive. So paano natin i-add? You may add only reactive to reactive, or simply, ang gagawin natin dyan, ipo-project lang natin itong ating apparent power sa dulo ng ating reactive power ng ating capacitor bank. So, vectorially added. Ang tawag natin dito, so sa EE, ang tawag is phasor diagram. Yan siya. Then, ipo-project ko lang din sa dulo ng ating apparent power yung reactive power ng ating capacitor bank. So, eto siya. So, therefore, kung saan sila ulit nag-meet, draw a line from the origin. Ito na ngayon yung panibagong apparent power ng buong circuit. So this is the new apparent power of the given circuit. So ngayon, kung papansinin mo kapatid, yung panibagong apparent power, mas lumiit. So ibig sabihin, nakasave. Okay, sino nakasave? Hindi tayo ang nakasave. Kasi kapatid, yung real power na kinonsume natin, the same pa rin. So, ito pa rin ang i-build sa atin. So, sinong nakatipid? So, kung titignan mo, yung new apparent power ng ating circuit, medyo lumiit. So, nung lumiit yan, tingnan mo tong angle na to. So, ito na ngayon, yung panibagong power factor angle. So, comparing to sa previous, mas maliit na siya. So, this would be now the power factor angle mu. So, nung nag-correct tayo ng power factor, mas lumiit yung apparent power na kailangang isupply sa atin ni electric cooperative. So, ibig sabihin, let's say, dati siya nagsusupply sa'yo ng 100 kVA, assuming, so after mong improve yung power factor mo, so mas maliit na yung kailangan niyang isupply. Instead na mag-supply sa'yo ng 100 kVA, pwede, supplyan ka na lang niya ng 80. Pero ang ibibill pa rin niya sa'yo, same pa rin kasi hindi nagbago yung real power. So in that case, from 100 na kailangan niyang i-provide, 80 na lang. So yung sobra doon sa dating 100, which is 20, pwede pa niyang gamitin ngayon yon pang supply ng ibang customer. Kaya palagi ang nag-uutos o yung nagbibigay ng instruction or mandatory for power factor correction ay yung mga electric cooperative such as Meralco. So sinong kailangan niyang i-mandate na mag-improve? Those are the residential at saka, not residential rather, commercial and industrial. Kasi si commercial at industrial, sila yung mga establishment that has low power factor. Kasi sila merong mga malalaking load. Pero si residential, so usually, hindi na kailangan mag-correct ng power factor. Wala naman siguro sa atin. No? Baka, wala. Sa mga mayayaman, baka sakaling meron silang elevator, escalator, 10-tonner na freezer sa bahay. So in that case, kailangan nila mag-correct ng power factor kasi malalaki yon. Pero kung normal house lang, so no need na for power factor correction. So kailangan lang yan pang commercial at saka industrial. So kung papansinin natin ngayon kapatid, after nating i-add ito na ngayon yung ating panibagong power triangle na kailangan i-consider. Okay? So, yung orange na yan, ito na ngayon yung ating net reactive power. At ang haba nito is what? Q sub C. Kaya loss-free, kung papansinin mo, hindi nagbago yung ating real power. So palagi, ang ating dinidesign dyan, what would be the size of the capacitor bank needed to improve this power factor from this value up to this value. So in terms of magnitude, kung gusto mong kunin ito, simula dito hanggang sa baba is the reactive power of our load, Q sub L. So in terms of magnitude, pwede natin sabihin, this is only the difference between the reactive power of the load initially minus the net reactive power. So ang tanong ngayon dyan, paano natin kukunin itong reactive power of this given load? So using the apparent power initially of this load, ano yung kanyang original power factor angle? So theta sub n or theta sub o. So ibig sabihin using the tangent function, tangent of the original power factor angle, ano yung tangent? Opposite. So, sino magiging opposite nitong angle na to? So, that is Q sub N at saka si Q sub C, which is the magnitude of what? Q sub L. So, that is simply Q sub L over what? Real power. So, therefore, using this equation, Q sub L is just the real power of the load multiplied the tangent of the original power factor. Now, same also, to get this value of the net reactive power, gamitin naman natin itong new apparent power. Anong angle? Theta sub n. So, same function, theta sub n, ano opposite? Q sub n over 1? P sub n. So, in that case, the net reactive power, that is simply PL multiplied kanina, tangent of theta sub n. So therefore, ano gagawin natin? So these two given value, i-substitute natin dyan. So anong makikita natin? So at this case, the size of a capacitor bank needed to improve the power factor Q sub C is the real power consumed by the load quantity tangent of the original power factor minus tangent of the new power factor. So yan na agad yung ating reactive power. At alam natin, reactive power, anong connection nila? They are connected in parallel. So ibig sabihin, kung ano man ang voltage drop dito sa ating capacitance, that is also equal to your source voltage. So using power formula, it is also equal to the source voltage squared over the capacitive reactance. So which is also equal, alam natin 1 over x sub c, it is equal to omega times c. Kasi alam natin, 1 over omega c is x sub c. Kaya 1 over x sub c is just simply omega c. Angular velocity multiplied by the capacitance multiplied to your E squared. So that would be the reactive power of the capacitor bank needed to improve the power factor from this value up to this new value. So yan na yung ating formula. So yan na palagi yan, no, kapag ka ang ating power factor correction, it is used under capacitor bank. So based sa problem, we want to improve from 0.65 to 0.85. So the apparent power of the load is 0.65. So kailangan natin yung real power. So to get the real power, kung babalikan mo, power factor. So power factor of the load or simply power factor, di ba? Kaya nga tinawag siyang real. That is the ratio of real over kanino, apparent power. So if this is the real power of the load, and this should be the apparent power of the load, so this would be the original power factor of the given load. So in that case, kung na tayo may problema, lalabas that the real power consumed by the load, it is always the product of apparent power and its original power factor. Okay? So wala nang problema. So i-retain na lang natin as kilo, no? kVA ito, so lalabas dito kilowatts, so therefore the reactive power should be measured in K bar. Okay? So kilovolt ampere. So you have now the reactive power. Apparent power in kilo, that is 5. Original power factor is 0.65. Okay? Multiplied tangent. Ano yung original power factor angle? So you have to take arc cosine of 0.65 minus tangent corrected power factor arc cosine 0.85. So agad, meron na tayo reactive power of this capacitor bank. Kaya kung naalala ang formula, this is just direct substitution. So 5 times 0.65 times tangent of shift arc cosine of 0.65. 2 minus tangent of shift arc cosine of 0.85. 2, 3 equal. So the answer would be 1.786 unit. It should be in terms of K bar. Yun ay ating final answer. Kuha ba? Any question regarding that particular problem? So that is the power factor correction using capacitor bank. No? So kapag nag-improve tayo ng power factor, ano talagang na-reduce? Ang na-reduce doon, yung apparent power supplied by the electric cooperative to a certain customer. So, ibig sabihin, medyo nakatipid siya doon. Hindi lang siya nakatipid, kumita pa siya. So, dati ang kanya sinusupply sa isang customer is 100 kVA. So, therefore, after na-improve yan, sabihin natin from 100 naging 80, so meron siyang savings na 20 kVA wherein pwede pa niyang i-distribute or pwede pa niyang gamitin yun to supply another customer. So, kikita pa siya ulit. Okay? Nakuha ba? Kaya palagi, ang nagpapa-improve ng power factor ay mga electric cooperative. Sino kailangan mag-improve? The commercial at saka industrial. Hindi na kailangan ng residential. Okay. So, number 18. A single-phase AC generator is supplying power to a load of 3,200 watts at 230 volts. So, let us consider the real power consumed by a given load, that is 3,200 watts with original power factor of what? 60%, or that is 0.6. Now, if the total loss is 10% of the load, what would be the savings in watts if the power factor is raised to 80%. So let us consider using capacitor bank or any given method, the power factor is improved from 0.6 to 0.8. Now, based sa problem, if we try to get the power loss, P loss, it is equal to 10% of the total load or the total loss, it is 10% of the load. Sino ba yung load na sinusupply ni electric cooperative pagdating sa mga customer? Hindi lang real power ang sinusupply niya. Actually, it is apparent power. Kaya nga yung ating mga transformer, anong rating? Naka-kVA, apparent power. So that is the apparent power of the corresponding load, no? S. So therefore, if the power factor is being improved, therefore, the apparent power supplied to a customer decreases also. So kapag nag-decrease yung apparent power supplied to the customer, magdi-decrease din yung cost. So therefore, nakatipid tayo. So lumalabas kapatid, that is only required, no, that is the change in the power loss. Okay, so paano ba kunin yung change in the given power loss? So that is the final power loss. Sabihin natin, new minus the old power loss. So saan natin kukunin yung ating new power loss at saka old power loss? Sabihin na lang natin, this is our power loss, new, that is based on the new power, apparent power when the new power factor is corrected to 0.8. So the old power loss if the original power factor is what? 0.6. Now, this given change, so since loss ang pinag-uusapan natin, so pwede yan positive at saka negative. So ano ibig sabihin? Kapag ito positive or negative. So kapag positive yung change ng power loss, ano ibig sabihin? Nag-increase. Increase yung loss. Pero pag nag-negative ito, ibig sabihin reduce yung power loss. So therefore, anong aim natin? Mabawasan yung corresponding loss. So kapag nag-negative ito, ibig sabihin yung ating new losses tumiip. So ibig sabihin nakatipid. Okay? So kung naging positive yan, the losses in the system increases. So ibig sabihin, mas magastos. Mas malaki yung losses. So since sinahanap natin dito, what is the savings in watts? So dapat lumabas dyan, it should be negative. So that negative equivalent to the amount of power loss that is being reduced to our system. Okay? So yung power loss, it is 10% of the apparent power supplied to the load which is already measured in terms of watts. So naka-watts na daw yan diretso. So therefore, pag kinuha natin yan, so the change in power loss, that should be equal, no, ano ba si power loss? 10%. So ilabas na lang natin si 10%. 10% in decimal, that is only 0.1. So this should be new. So the new apparent power minus the original apparent power. So paano ba kunin yung ating apparent power? So solving for the apparent power, alam natin, apparent power using power factor, apparent power, it is always equal to the power over the corresponding power factor. Eh alam natin, yung real power of the load constant yan. Hindi nagbago. Ang nagbago lang is yung apparent power. So, in that case, pwede na natin diretsuhin. You have 0.1. Ano na ang new real power? Using capacitor bank, this should be held constant. 3,200. Ano na ang new power factor? The new power factor, it is at what? 0.8 minus 3,200. I-divide na lang natin kanino. Ano yung old power factor? So that is only 0.6. 6. So, meron na tayong change in the given power loss. Kapag nag-positive yan, ibig sabihin, mas lumaki loss, lugi. Pero pag nag-negative yan, ibig sabihin, reduce yung power loss. So, kumita, nagkaroon tayo ng savings. Okay? So, pwede ko na sabihin, 0.1 times 3,200 plus. So, 0.1 times 3,200 multiplied na lang ng 0.8 inverse minus 0.6 inverse equal. So, negative, ibig sabihin, power is being reduced. So, you have negative 1,333 or 133.33 watts. So, ibig sabihin ng negative, reduced. So, kung reduce yan, so nakasave tayo with respect to the power loss. So, power loss is being reduced by 133.33. So, therefore, the savings in terms of watts, it is also equivalent to how much power loss is being reduced. So, therefore, the answer would be those time. Ba? So, any question regarding problem number 18? Okay? So, itong 19 and 20, this is just parallel operation. Hindi ko na isusolve. So, for number 19, bigay ko na lang yung equivalent circuit. And then, you try to analyze using parallel operation. So, pag small single-phase motor, so pwede nating express yung equivalent circuit ng small single-phase motor as what? Series RL lang. So, ito yung ating motor loads. Then, it was tested in parallel with resistance. Okay, connected to our source voltage. $240 volts. So, binanggit ng problem, this given resistance used to test this motor has a resistance of 160 ohms. And we have found out that the current in the given motor, pag kinuha natin yung magnitude of the current in the given motor, let's say I sub 1, based sa problem, this is only the motor takes 2 ampere. Now, the current in the purely resistive branch that is considered I sub 2. So at this case, although hindi siya given, kuha natin kasi meron tayong voltage 240 over 160. So the current across the pure R 160 ohm, that is only 1.5 ampere. And we have already identified that the magnitude of the total current, that is only 3 ampere. So ano hinahanap? What is the power of the whole circuit? So kapag kinuha natin yung power, total power. So that is simply equal to the power consumed by the resistance of the motor, inductance. So that is P sub R plus the power consumed by the resistive load. So pag kinuha natin yung power absorbed by the R, that is the voltage. Current, sino current yun? I sub 1, multiplied natin kanino? Cosine theta sub 1. So, sino si theta sub 1? That is the angle of your I sub 1 or that is the power factor of this given motor loads. Now, plus the power absorbed by the resistance. So, wala tayong problema doon. I2 is squared multiplied by R2. So, makukuha mo yung total power. So, ibig sabihin, ang aim mo muna dyan, mahanap itong angle ng ating I sub 1. So, kapag kinuha mo yan using parallel, I total is simply equal to I1 plus I sub 2. But it should be vectorially added. So, alam natin, ito 3 bar angle. Hindi natin alam yung kanyang angle. So, let us consider that is your theta sub t. That is the overall power factor. So motor load, anong current niya? 2. Anong angle niya? Since motor load, so negative theta sub 1. So plus, since the second branch is purely resistive, so therefore, its given current 1.5. Anong angle? That is 0. Since our reference here, the voltage is at what? 0. So masosolve mo ngayon itong angle theta. Pag nakuha mo si theta, substitute na lang dito. You may compute that the total power you try to solve. The answer here is 580 watts. So yan sagot ni number 20. And number 20, you have also parallel circuit. So pag kinuha natin yung ating equivalent circuit for number 20, so meron lang tayong two inductive load connected in parallel. Paano siya naging parallel? Magkaiba ang value ng current. So ibig sabihin, they are connected in parallel. Okay, so we have the source voltage here. Hindi na binigay kung anong value, but let us consider its phase angle, that is what? 0. So we have two loads connected in parallel. So meron tayo I1 here. Then we have I2 here. So at this case, given na lahat, no? So the value of our I sub 1, that is equal kanino? 20 ampere. At yung kanyang angle, theta sub 1, lagging, so negative 30 degree, kasi lagging. Then I sub 2, its magnitude, that is what? 40 ampere. At yung kanyang angle, theta sub 2, is what? Lagging, so negative 60 degree. Now, what current in ampere should flow in capacitor so that the circuit will have unity power factors? Ibig sabihin, gusto natin din improve yung power factor or the overall power factor of the circuit will become unity. So para maging unity yan, nag-connect tayo ng pure capacitor sa dulo. Okay, so we have your capacitance. So hinahanap lang ng problem, what would be the current here? Let us say I sub 3. Anong condition? No, kapag kinuha natin yung total current dyan, ay total, so let us consider ang angle ng ating total current. So the total angle, no? So since anong condition? Power factor is unity. Pag sinabi natin power factor is unity, kailangan natin kunin. So what would be the value of the current I sub 3? Anong condition? At the overall power factor or the total power factor of the circuit, that is equal to unity. So therefore, pag kinuha natin yung phase angle, that is the angle of your voltage minus the angle of your, sino to? Total current. So kung unity, anong lumalabas? This should be 0. At this case, the phase angle of your voltage, that is 0. So isa lang ibig sabihin, yung angle ng ating total current, it should be also 0. Kaya kapag pinag-add natin yan, using parallel operation, ay total, ano magiging angle? 0. Equal. So you have I1, ano angle? Negative. Theta sub 1 plus ano si I2, ano angle? Negative. Theta sub 2 plus I sub 3, ano magiging angle ng ating I sub 3? Kung babalikan natin, purely capacitor ito. Diba? Pag purely capacitor, balikan mo frequency response. Ano relation ng current at saka ng voltage? So kung naalala, sa pure capacitor, current leads the voltage by how many degree? 90. So palagi ahead yung current sa pure capacitor sa voltage ng ilang degree? 90. Kaya kung ang voltage natin is at 0, so your I sub 3, it should be at what? 90 degree. Nasaan yun? So andito yun. Ano? Babalikan natin yung ating frequency response. Nasaan yung frequency response? Dun sa ating pure capacitance. Okay? So, purely capacitive I leads E by 90 degree. So, kung nasa 0 yung voltage, ang current natin nasa 90 degree. So, this is 90. Kaya yung ating angle dito is 90. So, makukuha mo na dyan, using parallel operation lang, makukuha mo na yung ating I sub 3. So, pwede mo nang computein yan. Kuha mo 44.6 ampere. So, you try to compute. Okay? So, yan na yung ating mga final answer. So, yan lang. Hindi tayo nagbago, no? So, pag parallel, current is additive, yun nga lang. You have to include the corresponding angle at kagamit ka lang ng complex number. Kaya importante pagdating kay AC circuits, medyo gamay natin yung complex number. Okay, so I think that would do it para dyan sa ating AC circuits. Sinob lang natin lahat para walang problema. Okay, so in that case, pwede na yung ating AC circuits. So yan lang naman ang kailangan kay AC circuits. So kailangan alam natin si Ohm's law. You know the behavior of resistance, inductance, and capacitance across AC circuits. Idagdag mo lang yung ating impedance triangle and the computation should be done under complex number analysis. So which mean, kailangan recall nyo pa yung mga principles and operations under complex number para hindi tayo maligaw pagdating dyan sa AC circuits. Mapa single phase man yan or three phase. Okay? So I think that will do it. Thank you very much. So ingat tayo lagi. See you next meeting.